Okay, so welcome guys. My name is Arun. I have more than 10 years of experience working in various different domains, collaboration, IoT, and then security as well. So this is a new course from Network Kings, which is your CCNP to CCIE security technology class. Kind of aims to bridge the gap between the CCNP and CCIE technology. So we are kind of aiming to have individual technology classes rather than having full-blown mock-up labs. Right, so that way we can focus on individual products and individual technologies, go in depth and be as comprehensive and as detailed as possible. So what is the technology class all about? So basically it's going to put you towards understanding the Cisco security portfolio and the associated technologies. Okay, it's basically developed to give the students a quick and effective overview and prepare you for your CCNP and CCIE certifications. Okay, we are going to talk about security architectures, the product architectures, designing, planning, implementing, configuration, optimizing, and then obviously troubleshooting of those products. So this not only is going to prepare you for CCNP, CCIE certifications, it will be also be very helpful for your job interviews, and then it's going to also help you go back and apply these concepts to your enterprise networks itself. So talking first about the CCNP security. So like we all know, Cisco went through a change in the way that they do their certifications for the requirements. So CCNPs now require you need to do a mandatory core exam, and then there, depending upon which track you're doing, in our case is security, you can choose a concentration exam, which is in detail product-based exam. So when you do those two exams, you get certified as a CCNP. So the core exam, it basically focuses on the knowledge of the security infrastructure, right? Passing the core exam, it will also qualify you for CCIE security. So there's no more CCIE written exam now. All you do is you give the core exam, so you get qualified to either become a CCNP when you pass a concentration exam, or you can go ahead and schedule and book your CCIE lab exam, and you will be eligible for the CCIE security as well. The concentration exam, it basically focuses on emerging and industry specific topics. So here is what the current CCNP security looks like in terms of the requirements. So there are no formal prerequisites now. So earlier we used to have CCNA security as a prerequisite to CCNP security and so on. But now there are no prerequisites. But yes, it's always good to have at least CCNA routing and switching level knowledge. Okay, before we jump into the security side of things. So there is a core exam, which is the SCOR, the exam number being 350701. And then you have 6 concentration exams. You can choose any one of these to be able to attain your CCNP security. The 710 or the SNCF is centered towards firepower, which is Cisco's next generation firewall solution, which is now called secure firewall. 715 exam is centered around ISE, Identity Services Engine, which is, again, Cisco's next generation NAC, identity management, segmentation, and lots of different things. It's basically a AAA framework implementation product, right? So that is what 715 does. The 720 and 720 and 25, they are basically content security. So ESA being your email security appliance, and then WSA being your web security appliance. The 730 is SVPN, which is again a VPN only based exam. It covers a bunch of different Cisco flavors of VPNs as well as generic VPNs, primarily on your iOS, ASAs, firepowers. And then obviously there is AnyConnect for your client-based remote access VPNs. And then the final one, the 735, the S Auto, it basically focuses on automation. I'm sorry, anyone had any questions? Okay. So these exams, the concentration exams, go in very detail and are very comprehensive in the way that they are testing the product and the technology. The SCOR exam covers all of these products, but it does not go into too much detail. Okay, so SCOR, like I mentioned here, it basically tests the knowledge around the security infrastructure. So it's going to test you on firepower, ICE, the content security, VPNs. It is going to test you on infrastructure security, some of the basics of information security and cybersecurity. It's going to test you on that. It's going to also test you on stealth watch, things like CloudLock, Umbrella, but it does not go into a lot of detail. Okay, so it's basically just scratching the surface of all of these products just to give the candidates a feel for what the Cisco's security portfolio really looks like. The concentration exams is where you are really tested in depth on these products. Okay. Now moving on to the actual CCIE security. So currently, we are on version 6, and for people who are not aware, it's basically a lab exam. It's an 8-hour hands-on exam, and in the and when Cisco revamped their CCIE, they actually put in a design plan and design aspect as well. So design is not only now a part of CCDE. So every single CCIE now has plan and design as part of it. So there is going to be a separate section in CCIE security where you will be asked questions related to planning and design of the products. Okay. So these are the 5 domains that the CCIE security version 6 tests you on. The first one being perimeter security and intrusion prevention. This is basically going to be things like your ASA and your firepower, your next generation IPS and IDS. The secure connectivity and segmentation tests you around VPN, with the segmentation part coming into play, things like your TrustSec, ICE, and then things like your DNA center. Third is infrastructure security, which basically is your layer 2 and layer 3. So how do you secure your switching and routing? How do you secure your management planes, your control planes? How do you secure routing protocols? How do you secure against maybe your broadcast storms and things of those nature? So, okay, so that is basically covered in infrastructure security. So that covers the iOS and the iOS XZ operating systems and platform. The identity management, information exchange, and access control, it basically involves ICE and a lot of integrations going on with different products. So things like integration with SecureX, your CDR, your CDA, things like PX Grid. When you integrate ICE with maybe Firepower, any other device, AMP. So all of these things, they would fall under the 4th domain. And then the 5th is the advanced threat protection and content security. Content security is, again, your WSA and ESA, and your advanced threat protection is going to be centered mainly around malware protection. So that would be products like your AMP, which is basically part of Firepower, which is basically part of your content security. And there is a separate product or a completely separate solution or service, which is centered around endpoints only for endpoint security. So that falls under your advanced threat protection. Okay, so within this technology class, we are trying to cover all the products and all the technologies and services that both your CCNP securities and CCIE security test you on. Okay, so if I move next here, give you a little glimpse about what the technology class is going to be all about. And we are going to assume that you do not have any knowledge about any of these products or technologies. Okay, so every single product here that you see listed, and you'll see it listed on the next slide as well, we're going to be talking about and discussing about these from scratch. Okay, so when I talk about ASA, when I talk about FTD, ICE, I'm going to assume every single one who joins the class that you do not have any knowledge about any of these products. Okay, so again, there are no formal prerequisites for either these certifications or the class, but it will really be helpful to have either a CCNA routing and switching certification, or at least the knowledge that goes into that. Right, because obviously I am not going to talk about how TCP works or how HTTP works, or when I say that, hey, I need to configure something to work over TCP port 22, I would expect you to know that, okay, that is SSH, right? So we are not
Arun,
going to know.
sorry to interrupt you. So I just wanted to tell you everyone. So those who want like any placement assistance from networking, so we have been hiring for many companies, and what they are looking for in the candidates. So they are definitely looking for the FTD knowledge, ICE, or VPN knowledge, but they specifically ask the headers like TCP, UDP, ICMP. So whatever you might have learned in CCNA. Okay, so the guys who are joining with us for the CCNP to CCIE security, we will be also giving you TAC engineer videos, which will be consisting of all the header videos, so that when you will be applying for TAC jobs, you will be definitely able to crack the TAC interviews as well. Okay, yeah. So just to add on, if anybody wants to take up this course, as Arun said, so you should have at least a CCNA knowledge to enroll for this program, which is CCNP to CCIE technology classes. Yeah. So Arun, you can continue. Thank you.
Okay. So the technologies that we'll cover throughout the class. So we'll be doing firewalls, ASA, FTD, and zone-based, which are your iOS-based firewalls. We're going to cover VPNs, ICE, ESA, WSA. We're going to talk a little bit about SDA as well, how it implements with ICE, since ICE is a very integral part of SDA and Campus Fabric. So we are going to discuss about that, and then Umbrella as well. Okay. And this technology class should help you to gain the knowledge and skills you need to master the technologies within the CCNP and CCIE security blueprints. And as mentioned, also to crack your job interviews. So here's the technology class outline, basically. So I've mentioned the number of hours that we'll cover, and I have a separate outline detailed PDF that I'll bring up after this. So this is how the outline is going to be. Okay, so starting with ASAs, we're going to discuss next generation firewalls, next generation IPS, which is secure firewall. When we are going to talk about VPNs, I'm going to give you a little primer about cryptography as well. Okay, things like your PKI, why do you need it, how do you need it? So a lot of the things that go into PKI fall into the category of a sysadmin rather than a network engineer, to be honest. But I'll still cover a lot of those things because they would be really helpful when you go in and set up your own certificate authorities, and then start to issue certificates, and start to understand how VPNs work when you're trying to do pre-shared keys versus you are trying to utilize PKIs. The fourth module is going to be based around infrastructure security. Then we have your content security, identity services engine, and then we're going to discuss StealthWatch as well, okay, which is Cisco's NetFlow analytics solution. We are going to also talk and go over Cisco AMP, which is AMP for E. This is basically AMP for Endpoint, which is the endpoint protection, malware protection product. And then I will also discuss TG, which is ThreatGrid, which is Cisco's malware sandbox. Okay. And then we're going to finish this out with Umbrella, which is Cisco's OpenDNS solution. So bringing up the, so this is going to be the actual outline for what all is going to be covered within each product. So like I said, I'm going to assume that you do not have any knowledge around any of these products. okay? And we are going to be working right from scratch, right from bootstrapping the product, doing the basic configuration, understand how things were, going over traffic flows, routing, doing NADing on your firewalls. And then with ASA, we are also going to look at MPF, which is the inspection policy. We're going to talk about transparent firewall, QoS, and then we're going to finish this out with redundancy. Okay, we're going to do high availability, clustering, and then security context. So wherever necessary, I have mentioned the versions of the products that we are going to use. I'm not using necessarily the versions that you're going to see in the exams, okay? Because the versions of the exams are not really up to date, obviously, but I really want to work on mostly the latest and the greatest versions, because those are typically also the ones that you will see a lot in production. And then they're also much more stable, and they have much more features that we can discuss, and they kind of make the product worth learning and worth understanding. Okay, so wherever necessary, I've mentioned the version that we'll use in the labs. So that's your ASA. And then for the next generation firewall and the next generation IPS bit, the secure firewall, we are going to be using version 7.1, which is the current latest version for firepower. It is because it is stable. It introduced a lot of different things. It also uses SNOT version 3. And if you're not aware what that is, that's perfectly fine. We're going to discuss everything that goes on why you need SNOT and why SNOT is there. So previously they used to use SNOT version 2, and now we are using SNOT version 3. So there's a good amount of difference in both of these. So that's why I wanted to start with 7.1 so that we can cover SNOT 3.0 and understand why it's much better than the previous detection engine. So this is all that we'll cover. So in most of these, you're going to see that we are trying to focus a lot on the deployment part as well. So if you saw here, we're going to be talking about ASA deployments. That kind of involves your planning and design aspect as well, that how you probably deploy from maybe from a data center perspective or from a perimeter edge perspective. Okay, so same thing we're doing here. We're going to go over the deployment of firepower, traffic flow, the ACPs, your device and object management, network discovery, our intrusion policies. We're going to look at NAP and the preprocessors, file detection, and AMP. So this is where AMP for network comes into picture. Okay, we're going to talk about SSL decryption, identity policy, correlation policies, and event analysis. Okay, so we are also going to see a lot of integration with firepower. So we're going to see integrations with ICE and maybe integration with AMP for endpoint as well. So moving with the, so the next module that we'll cover is cryptography and VPN. So this is going to cover the VPNs from iOS, ASA, and firepower perspective. And then for our client-based VPNs, we are also going to do AnyConnect. So like I said, I'm going to cover cryptography, a lot of the basics for cryptography. Okay, we are going to talk about IPsec and PKI. Different VPN types, modes. So we are going to see S2S VPNs, Get VPN, Flex SSL. And then we're going to look at two types of remote access VPNs, which is basically your clientless and AnyConnect. And then we'll also look at how all of these products, they do load balancing for VPN and HA. So VPN is very important, especially nowadays, and especially for the past 2 years since the start of the pandemic, because most of the people have been working from home. Next would be your infrastructure security, which is a layer 2 and layer 3 security. So we're going to look at what are some of the layer 2 threats and how do you mitigate them. We're going to see how do you implement NFP, which is Network Foundation Protection Framework. We are going to understand and secure our management planes and control planes on our switches and routers. Okay, how do you secure the management traffic? Okay, your SSHs and your tailnets, how do you secure them? And even things like your net flows, and how do you secure those? We're going to see how do you secure your infrastructure device images and the config files, okay? Because if some of those products get compromised, and those are some of the things that are stolen. First thing, so we're going to see how do you secure that, and then we are going to also look at how do you secure your routing protocols, okay, your RIP, your OSPF, VIGRP, and all those things. So we're going to see how do you secure those as well. Moving on to the content security part, WS and ESA. So I've kind of clubbed it into a single domain. So we're going to look at proxy services from a WSA perspective. We're going to see L4TM, user identity, URL filtering, bandwidth control, AVC. AVC is basically application visibility control. So we're going to see AVC as part of the firepower and next generation firewall as well. SL decryption, outbound data security, and then when we move into the email security bit, we're going to talk about SMTP. So we're going to see how SMTP really works, right? If you have not really been a sysadmin, then I'm pretty sure a lot of the people joining in would not have worked directly with MS Exchange and email protocols for that matter, right? So we're going to look at how SMTP works, what SMTP relay is, and then look into the packet flows and reputation filters. And then we're going to spend some time on AS and AV, which is anti-spam and antivirus. We're going to look at content filters, outbreak filters, and content security in general. So that will be the content security module. ICE, we're going to be looking at ICE version 2.7. Which was the last recommended release from Cisco. I might, when we are doing the labs and when we're doing the class, we might go through and upgrade it to 3.0 and see what the differences are. But the major differences were in licensing, primarily when they moved from 2.7 to 3.0. So I'll cover it as part so that you are aware from maybe an interview point of view that what were the real differences in it. But for the most part, things remain same from 2.7 to 3.0. So we're going to work through, so there's a lot of content within the ICE module in terms of understanding the protocols, okay? And ICE is a very complex product, to be honest. So we are going to look at very detailed into AAA, Radius, and TACAX Plus, okay? We are going to look at a lot of packet types, message types that go into deploying these, what do you see, what do you not see, and then we're going to spend a considerable amount of time on understanding the IEEE standard 802.1x, okay? Then we're going to work towards an understanding how do you plan ICE deployments, because again, it is a complex product. There are some things that you need to be aware when you're planning an ICE deployment. Otherwise, it can get really problematic. Okay, we're going to integrate ICE with an Active Directory. Again, very important. We're going to look at MAB, which is MAC authentication bypass. You're going to see how it differs from 802.1x and when to use MAB and when not to use MAB in deployments. We're going to look at wired and wireless 802.1x. So this will involve having a wireless LAN controller, and we'll be doing the configuration of the wireless LAN controllers as well when we do the wireless 802.1x. We're going to look at guest access, ICE posturing, device profiling. Posturing and profiling is again very important. And then we're going to look at BYOD, which is bring your own device. So in the current scenario, a lot of organizations allow people to get their own laptops coming into organizations. So how do you handle those BYOD situations from a network access control and identity management bit? So we're going to look at that. Then we're going to spend some time on segmentation, which is your trust sec part. We're going to look at MACsec as well. And then we're going to look how ICE looks in an SDA deployment and what it kind of tries to achieve in an SDA deployment. So we might not necessarily have labs for SDA because it's basically a hardware-based product, SDA, or it's the orchestrator basically within the SDA deployment, which is your DNAC. It's basically a hardware platform. You cannot virtualize it. I mean, at least not with sufficient resources. It is a very complex and a very heavy product. But I'll still try to go over and make you understand how it kind of fits into it, what a campus fabric is. So again, these things are more to help you see what the product or what the technology is all about, and maybe answer a couple of questions if things come up in your job interviews. We're going to spend some time on Stealth Watch. Then we're going to look at NetFlow and how do you deploy NetFlow and what would be the different deployment scenarios. We're going to look at NetFlow from an iOS and iOS XZ perspective. Not much difference between iOS and iOS XZ with the exception of some commands. So we might just look at iOS XZ with the help of a CSR 1000V. Which can be quite easily virtualized, and it's quite easy to deploy as well. And then we're going to look at and deploy an SMC and a flow collector to get some logs into Stealth Watch and see what it looks like when you're trying to maybe look at the traffic that's going on in your network. And then we're going to look at CTA and ETA, okay, which is basically Cisco's analytics, CTA being the threat analytics, and then the ETA being the encrypted traffic analytics, okay, or analysis. Next would be the AMP for endpoint. This is, again, a completely separate service than what we see as part of AMP for network. There's completely, so this is a cloud-based solution for your endpoint protection, malware protection. So we're going to look at the licensing for this, what the AMP for endpoint console looks like. I'm going to cover a lot of different best practices. How do you deploy policies in one go? And then how do you keep coming back and fine tuning it? I've done some good number of production AMP for endpoint deployments from scratch. And then I've also helped a lot of customers do their optimizations for AMP. So I'm going to cover most of the best practices. We're going to look at some investigations within the AMP for endpoint console. How do we take care of file trajectory and device trajectory? So for example, a device has been flagged as executing a malicious file within AMP for endpoint console. Now, how do you investigate it, right? How do you see how that file came into play, or from where did the file come into that PC or the workstation, and who did what? So we are going to see all of that within the AMP for endpoint console, very integral part of doing any sort of investigations within the AMP console. I'll also talk about ThreadGrid, which is Cisco's sandbox solution. It works both with AMP for network from an ESAWS perspective, from a firepower perspective, or from the perspective of AMP for endpoint. Okay, so you can deploy it two ways. You can have cloud-based, or you can have on-prem. If you are dealing with, if you're dealing with DoD, military and government-based organizations which do not want to send their files to cloud, then you can put these on-prem as well. So we're going to look at this. We're going to see how it does the file analysis for the TG, and then we're going to also look at CDR and SecureX. Again, some of the things you are not going to be tested on the exams, either the CCNP Security or the CCIE Security. Maybe you might get a couple of theoretical questions, okay? But that's the whole premise, is to cover most of these products in as detail and be as comprehensive as possible, and not just cater to what the blueprint has. And then we are going to finish this class with Umbrella. Okay, so this is again an acquisition for Cisco. They acquired this OpenDNS solution. So I'm going to talk a lot of things here about DNS. Why do you need it? What is it required for? I mean, we obviously know that it's for name resolution, but we're going to look at a little bit more than that, and then why it's important, and then how can you natively secure DNS, and how does Umbrella come into picture, and then some of the use cases for Umbrella as well. Yeah, so that is going to be the complete outline for the technology class. Okay, so I'll probably pause here and take any questions if anyone has any.
Yeah, guys, you can ask your doubts if you guys have. So this is the new program which we are introducing now from CCNP to CCIE technology classes, and almost all the security devices from Cisco perspective we are going to cover. Already you can, this video recording is also available on YouTube. You can always go and refer it back. So what we have discussed in the course content. Okay, and thank you, Arun, for just giving the outline in a very good, effective manner so that everybody understand. So yeah, so guys, you have any doubts like regarding any like also this full program is with lab access. Okay, if you guys want, I can show you. Just let me know if you want me to show the lab access. And rest, you guys have any technical question or any career question from us, you can ask.
Hello.
Hello, yes. Yes,
Good evening. Good evening, sir. Sir, I want to know, as far as Cisco goes, they are pioneers in switches, router, this kind of equipments. But when it comes to security, vendors like Palo Alto and Checkpoint are having a much greater edge. So, what are your views on taking the priority on Palo Alto
So
and
yeah, I have
Checkpoint over
answer to
this
this.
CCNP?
Yeah.
Yeah.
So Arun, you want to add something first in this?
Yeah, sure. So from my perspective, the technologies and the underlying whatever it's happening from a security perspective. So let's just assume we're talking about firepower. So the IPS and then signature based malicious control, your application visibility. So most of these concepts and technologies, they remain the same. What changes is just the product. Okay. So if I talk about Palo Alto, for example, they are kind of doing the same thing within their product. It's just that they have a different architecture. Okay. Another example would be they have their own sandbox, which basically they call firepower. Cisco does the same thing, maybe with a different algorithm, maybe with a different AI and ML algorithm, and they call it threat grid. So it's primarily to understand how these technologies really work, and then it gets easy when you try to move to a different vendor because you already know about 80% of what the technologies are underlying. All you need to understand is just the product and maybe the licensing and how do you, maybe if you're in pre-sales, and how do you sell and do the POCs, etc., etc.
Okay.
Yeah, I got, sir. What when
So
you try?
I want to add, Cyril. I
Yeah.
want to add also. So
Yeah.
basically, let me tell you about my perspective because I closely interact with HRs and the recruiters, those who hire from networkings.
Yeah.
Okay, basically, when we discuss about technologies, many companies they are using Cisco or ASA or FTD products. ICE is also one of the great product. So when you go and learn Palo Alto or maybe Checkpoint or FortiGate, so you learn from the tech, what we call vendor, like only
Perspective.
one, yeah, vendor perspective. So, but when you go into Cisco security, there are a lot of products in Cisco security. Just understand first you learn the ASA firewall. Okay, then you go and learn the FTD, which is next generation firewall, which is already having competition with Palo Alto and Checkpoint. Okay, so ASA is a very basic firewall to grab the knowledge from the basic perspective. But if you go and learn directly Palo Alto, it is like you have a Ferrari directly. Okay, but you do not know how to drive. Okay, so but yes, many people they want to go with Palo Alto, and but our trainers will train you Palo Alto in a way that you will understand that also. But here I'm talking ASA is a very basic firewall in terms of Palo Alto. So if you are starting your career as a network security engineer or want to learn from very deep dive of technology, that what is going inside the packet, then this program is better, because a Palo Alto trainer will not go deep dive into the VPN headers, not go deep dive what is going inside the packets. So if you want to learn from the packet level perspective, then Cisco training and Cisco certifications are best.
Yeah, and one more thing, sir, I have heard from this is from the job perspective. How far you weigh this? This is part of cybersecurity only, right?
Yeah.
You're foraying into cybersecurity. So there is something called pen testing, vulnerability testing, ethical hacking, and related to more
so
on
that is
the
basically
software.
yeah, that is
My question is if you integrate this knowledge with bit of that, or I want your guidance, How does, like, what is the,
So,
how you become more employable or skilled to get attracted
okay,
by
so
an
I
employer
just
in
had a
Cisco?
meeting with the one company director, Accenture. Everybody knows about that company. Okay, I had a meeting with IT security director of that company, and what he said. So 80% of the jobs are in cybersecurity are in the defensive side, not in offensive. And all 80% candidates in the market, they are preparing for offensive. Means they are preparing for penetration testing, they are preparing for bug bounty, but 80% of industry IT security jobs are in the defensive, like network security engineers or the guys who defend the networks and defend the cyber security things, like checking the loopholes and all. So if you see from that perspective, like in cyber security, 80% jobs are for those guys who are into networking, who have done CISSP, which is security information security auditors, or maybe those programs which are directly relate to the information security auditing. Okay, not the penetration testing always, not always what we call that hacking, all those stuff. Okay, that you can also check that. Then defensive is more reliable, and all these programs what we are delivering here, this falls under cyber security umbrella also. And this is, you can say, this is known as the defensive cyber security, and Cisco security is a good way to start your career into network or cyber security defensive side. So Arun, you want to add something here?
Yeah, so
And sir,
you actually put
one,
that
yeah.
yeah, you actually put that really well. So so a lot of demand is around the defensive side of things. Things like a penetration testing and a vulnerability assessments. They kind of, so vulnerability assessment you can also put on the blue team side or the defensive side. Okay, but the demand is there for penetration testers, but it's not as much as on the defensive side or the network security side. So yes, network security and whatever I discussed, your VPNs, your identity management, your network access control, and all these things, they all are or they all fall under the cybersecurity bit.
And sir, one more thing, do you all assist with the dumps for passing the exams when,
No, we do
because
not provide dumps.
okay, but in how far when we are sure that when we complete this course, are we going to clear it? Like, what is your take on this, sir?
So obviously everybody knows how to crack your exams. I'm sure you are not a beginner in this industry, but this is a live session on YouTube also.
Yeah,
So
yeah.
obviously we cannot answer. That's your
Ah,
choice.
okay, sir. Yeah,
Yeah.
no
So
problem.
this
Thank you,
is,
sir. Sorry
yeah.
to ask.
Yeah, no worries, no worries. Yeah. So guys, anybody have any other question? So obviously we are here to provide the technology classes in a very effective manner. Okay, definitely this is our guarantee that you will learn from the industry perspective and you will be able to clear interviews. This is the whole purpose of creating courses at networkings, that whenever you learn from engineers, you will directly able to clear the technical interviews. And what interview in interviews, whatever questions you will be, all the questions what being asked. So definitely the trainers, those who from industry, they have given a lot of interviews earlier. They will always guide you whenever, suppose if Arun is teaching you site to site VPN, so automatically, because he already gone through a lot of interviews in the past, so he will always guide you, okay, in site to site VPN this can be asked in interview. Okay, so according to that we are going to train you, and this whole course is almost of 100+ hours. Okay, so where you are getting not just firewall knowledge, but you are getting other products also, like email security appliance, web security appliance, firewalls, ICE is again a good product, and this is the most powerful AAA engine in the device in the market right now. So there is another one also, Aruba Clear Pass, but ICE is something which is mostly used by all companies, because mostly all companies uses Cisco products, and Cisco is more compatible with its own devices rather than the other vendors. I hope it makes sense. Now you got the point. Why Cisco security? Why not Palo Alto or Checkpoint? So if you are a beginner, if you want to learn from zero level and you want to go deep dive into security, this is the program. But if you are working in industry where you just need to brush up your security skills, you just need some firewall into your resume, then go for Palo Alto or Checkpoint. If you just want to add on as a firewall, but if you want to make your career as a network security only, then this program is going to be more effective. Okay, all the brochures and outline will be emailed to you, okay, so that you will check it further. And how you guys can connect our team for admissions. That link already, I think we have shared. Gaurav sir, where is the link? Please share in the chat.
Yeah, guys, any other question you can directly ask Arun. Arun gonna help you with the whatever the queries that you have.
Sir, one question from my side.
Mm-hmm.
I actually enrolled for this CCNP Security. So is this the same course which I'm getting in CCNP 2?
So Vamsi, that we are going to internally discuss if we can we can merge this, or might be we cannot. That is still in discussion internally. Okay.
That we can discuss separately, guys. Don't worry.
Okay,
Anything related to technology, anything related to the technical thing or the courses, you can ask here.
Lab रह गया मुझे दिखाना.
Hi sir, this is Jen.
Yeah, Jent.
Yeah sir, I have some queries. So I am asking regarding the production. So could you please give me the idea of how I can upgrade the ASA to FTD? So related to production, I mean,
Arun sir, please, can you please help him?
Yeah, I didn't get the question. Could you repeat that?
So he's saying, like, if they want to upgrade in real industry, if they are working on ASA right now, but they want to migrate to FTD, what could be the steps?
Right. So we are going to cover that in the class. So we're going to see how you can migrate or move from an ASA to an FTD.
yeah.
So that is something that we'll cover in the class. So if you just want to be very brief, so you do have an ASA to FTD migration tool where you take the configuration backup from the ASA, put in there, and then it basically applies that to an FTD device. Okay, so that is one way to do it. If you are running ASA with firepower services, then you can flash that ASA and put in the FTD code on top of it.
Okay, thank you. So you mentioned VPN load balancing also. So what is it? I didn't get this.
Load balancing. So I talked about load balancing from the VPN perspective.
So over the Argent, that's, I think, a VPN, like if you have one VPN, okay, but if you have multiple VPNs, you can share load balance the traffic on the VPNs. I think this was the context.
All right.
Okay, so guys, this is the lab access, okay, so which you all be getting with this. So this is, these are the labs. I think, Jent, this is your folder, right? So yeah, so this is FTD lab, I think, which you can also use. Okay, so you can see firepower devices and firepower. And so there are a couple of labs which you can use from this server, like WSA, redundant. So you can just check the Cisco ICE product also there, right? So this is created by one of our student, and there are some other labs also. You can see multiple labs are there. There is not only one lab, there are multiple labs where you can practice all the devices like firepower, ESA. So these all devices will be almost covered ASA. So this is one of the device ASA. So this is firepower, email security appliance, Cisco ICE. Okay, and whatever devices is required more, like there is AMP also, so which we can work also on that. Okay, so mostly all Cisco products will be covered into this until your course run. So suppose you starting this batch today, or suppose by next week. Okay, we are planning this batch from
Saturday, Sunday, and from coming Saturday, Sunday.
From coming Saturday, Sunday.
Yes.
So just to reiterate, so this is going to be mostly a hands-on, no PowerPoint, no slides kind of a class. So I'll keep the slides to as minimum as possible. But I still want to cover a couple of things. initially for the very basic and also from the SCOR preparation perspective that covers a good amount of theoretical knowledge on a lot of different cybersecurity concepts. So I have some slides prepared for that purpose. And then before that, I'll just show you what we'll cover as part of the theoretical bit, right? So this is the 350701 SCOR exam. Okay. If you're going to look at the first domain here, the security concepts, a lot of the things in here are basically your theoretical concepts, right? So things like your explains and your compares and your describe. Okay, so things like your viruses, Trojans, DDoS, all these things. These are some of the attacks: SQL injection, buffer overflow, path traversal, cross-site scripting, forgery, and a lot of these PKI SSL based concepts. So a lot of these things we're going to cover first up. Okay. And then once we are down with this, then for the most part, it's going to be primarily very hands-on and, mostly whiteboarded throughout the class. Okay. So let's start then. Okay, so this is going to be the first module. We're going to cover a lot of fundamentals of cybersecurity in here. Okay, so here's the agenda and the content for this particular module. So we'll go over some overview of cybersecurity. We're going to discuss how cybersecurity differs from information security or InfoSec. We're going to look at CIA triad. Then we're going to discuss a good number of cybersecurity frameworks or compliances. We're going to talk about assets, threats, and vulnerabilities. We're going to talk about risk and how to manage risk within an enterprise from a cybersecurity and from an InfoSec perspective. And then to end this, we are going to talk about the common vulnerability scoring system, or CVSS. So a lot of this information is going to be very helpful throughout the class, both from a certification perspective and also from industry perspective. Okay, things like your interviews and when you're trying to look at a lot of documentations or maybe go through a lot of concepts online, this is going to be really helpful to understand all of these. Okay. So starting off with the cybersecurity overview. Okay, so basically what cybersecurity is, it is the ability to protect and defend the use of cyberspace, okay, from cyber attacks or from cyber criminals. Okay, and this definition is the way that it is being defined by NIST. Right, so NIST is a US-based organization which has a lot of special publications out, which kind of shows or compliances around a lot of different things that are how to design your cybersecurity. How do you deploy and implement your firewalls? How do you use endpoint protection? And all those things from a generic perspective, they push out what they call as special publications. And we're going to talk about NIST when we talk about the framework. So this is primarily based in United States. So a lot of DoD and a lot of organizations within the United States, they kind of use NIST, but it's not primarily meant only for United States. So even if you are India, I mean, you would see a lot of people referencing going back to the NIST framework. Even myself, if I'm trying to implement something or maybe design something and I am not really sure if I am doing it right, the first thing that I do is I look at the specific vendors' best practices, right? So in our case, it's going to be Cisco. So Cisco has laid out its own best practices, its own recommendations for all of its products. Okay, how do you deploy it? How do you optimize them? What's the best way to troubleshoot them? So I typically do this, and every single vendor out there, be it Fortinet, be it your Palo Alto, be it your Checkpoint, all of those guys do the same thing, right? And then NIST, on top of it, does lay out a generic outline. Okay, so let's say if it's a firewall, how do you deploy it properly, or how you design it if you're trying to protect your perimeter versus if you're maybe trying to deploy it within your data center. Okay, the things of those nature. Okay, So cybersecurity basically lays out your framework on how you are going to protect and secure anything that is vulnerable to attacks. Okay. When I say anything, I mean anything, which can be your computers, your devices, your networks, programs, and servers. Okay. So it is kind of like a very broad picture on how you kind of protect all of these. So you need to understand this, that cybersecurity protects and secures anything, okay? Anything which is vulnerable to a hack, to an attack, or to an unauthorized access, right? So unauthorized access can also mean your server rooms, okay? Your buildings, okay? So those do come as part of unauthorized access as well, okay? And this will be really important to understand when we look at things like how does it differ from information security. Okay. In 2020, so this is kind of like a couple of years back of data, but it does give you a broad picture on how much it costs an organization as a whole, okay, if there is a data breach or there is an information leak that happens, right? You must have seen the likes of Twitter, Facebook, they have all gone through some sort of data breaches. In India, we have got Zomato and all of these things, they have been data breached. So it does cost the organization a lot. And if you're going to see here in 2020, the average cost was $3.86 million globally, okay? And then in the United States, it was around $8.64 million. So this was 2020, when we were within that pandemic period. And since then, up until now, cyber attacks have increased twice or maybe thrice or maybe even 10 times, okay? We do have a lot of these statistics for United States, you know, but even if I talk about India, there has been at least an 80% rise, or I should say 80% of the organizations out there, big or small, have been involved in some sort of a cyber attack in recent years. Okay. And that kind of also is the reason why there is an increase in demand of people like us who are part of network defense, okay, who are part of cyber defense, who are part of blue teaming, right? Now, cyber criminals, they typically target what is known as PII data, okay? So there is two types of data. There is PII, which is things like your names, your addresses, the identification numbers, okay? In US, you have SSNs or social security numbers. In India, you can have things like Aadhaar card numbers, PAN numbers, okay? All of these fall under PII information, okay? Date of birth, right? Things like your credit card information, okay? These things, they get leaked and then they are sold off over dark web, okay? If you're not familiar with dark web, it's basically kind of like a chore bazaar kind of a thing on the internet side, okay? Where you can get any sort of a data for any price, okay? So if I'm a hacker, I can do a data breach, I can extract all that database and I can put up on that marketplace to sell. And there are lots of organizations, a lot of state-sponsored people who are willing to grab that data, buy that data for, I mean, for whatever price, okay? In comparison to PII, there is PHI as well, which is the health information, okay? Unfortunately, in India, we don't have a lot of importance that's given to patient records, okay? Things like their files, their diagnosis, et cetera, we really don't do a lot to protect that data. But outside of India, there is a lot of compliance that goes into healthcare organizations, your clinics, your hospitals, your research centers. They are bound by a compliance framework, which is known as HIPAA, okay? And it does penalize these organizations with hefty fines if there are data breaches, which involves patient records being breached or leaked. Okay, when we talk about the cybersecurity frameworks, I'll talk a bit more in detail about what HIPAA is and what the penalties are. Yes, Mohammed, you had a question. Mohammed, you raised hand. I think you're on mute probably.
हेलो
Yes.
वॉइस नहीं आ रही थी इसलिए ओके
Sorry.
वॉइस नहीं आ रही थी अब आ रही है
So audio was not there.
नहीं अभी आ रही है ऑडियो एबल टू ऑडिशन एबल
Okay. So how much did we miss? Did you miss?
जस्ट 10 minutes slide
Okay.
No,
So
it was okay for me. Like I
so
had no
everyone
issues with
else
your
can
voice.
hear me well.
Yeah, we can hear you.
Okay.
Yeah, we can hear you.
Okay. Yeah. So Mohammed, probably just grab a set of headphones if you have.
yes able to listen here
Okay. So continuing, as the last point, I have mentioned that concepts such as pandemic, which we saw with COVID-19, cryptocurrency or the blockchain technology, and obviously since a lot of us have been working remotely, they have kind of increased the number of cyber attacks. Okay. Now, talking about cybersecurity domains, a strong cybersecurity strategy has basically different layers of protection to defend against any sort of cybercrime. Okay, this basically includes cyber attacks that attempt to access, change, or destroy any data, maybe extort money, right, from users or organizations, like we see in case of ransomwares, right, or aim to disrupt normal business operations, right? Things that we see kind of like with denial of service and distributed denial of service attacks. Okay. And when I say layers of protection, I mean that you have your perimeter security, which is through firewalls. You then have endpoint protection. You have antiviruses and anti-spam. You have email protection. You have proxies or web protection. You have load balancers to give some sort of a protection against denial of service and distributed denial of service. You implement things like high availability so that your servers or public facing servers, they are not disrupted by any sort of single attacks or anything. Okay, so you need to have different layers of protection, right? Now, there are some countermeasures that we should address, right, depending upon what we are trying to protect. So we can divide these countermeasures, or I like to call them as domains. First one is your critical infrastructure security, right? This involves basically practices for protecting the computer systems, the networks, and other assets that maybe the society and the public relies for things like national security, economic health, and public safety, right? An example I gave was for NIST, which is basically National Institute of Standards and Technology, right? Which have created a cybersecurity framework to help organizations for this particular purpose, right? Next, we have network security, which I'm pretty sure every one of us would be familiar about, right? These are security measures or practices for protecting a computer network, right? Your LANs, your WANs, your data centers from intruders. And network security basically involves protection for both wired and Wi-Fi networks. Next is your application security. Okay, this basically is used to protect, again, as the name suggests, it's used to protect applications, okay, both on premises and in the cloud, okay. So people who are developing these applications, they follow something that is known as an SDLC, okay, which is basically security, which is built at the design stage, okay, which is basically considerations on how data is handled, how to do user authentication, etc., for that application, okay. And your SDLC is basically secure development lifecycle, okay. So with every single step within this within the application development, you have some sort of a security going in to actually create secure applications, Next is your cloud security. Currently, we are in a phase where a lot of organizations are opting for cloud security. And these are, I would say, public clouds, okay? Things like your AWS, Azure, GCP, or Google Cloud Platform, things of those nature, okay? So cloud security, specifically, true confidential computing that encrypts cloud data at rest, which is in storage and in motion, okay, and in use. So we need to have cloud security function for all three of these things. Whatever data is stored in the cloud for the customers, which is the storage security, data that is in motion, right, from the organization to the cloud and from the cloud to the organization, or probably anyone, me accessing maybe anything stored in Office 365 or maybe OneDrive, right? So that is basically data in motion or data in transit, right? Or maybe data in use, which is basically data which is during processing, right? So cloud security should have protection for all three of these things, taking into consideration customers' privacy, okay, confidentiality, the business requirements that the customer has, and any regulatory compliance standards, right? Things like it could be maybe PCI DSS, which is credit card data handling. It could be things like I mentioned, HIPAA, which is for your PHI information. It could be things like GDPR, which is basically data protection within the European Union. Okay, so these are some of the compliance standards. We'll go over these in more detail when we cover the cybersecurity framework. Next is your information security, basically. So, like I said, up until now, I've talked about cybersecurity, which kind of protects everything within a cyberspace. It can be your mobiles, computers, networks, servers, applications, etc., right? How does it differ from information security, right? So information security, as the name suggests, only protects the information. It only protects the data, okay? And it protects the data against three things: confidentiality, integrity, and availability, okay? And that's what we'll talk about the CIA triad when we look at CIA. But information security only aims to protect the data. It does not aim to protect the storage, the mobiles, the networks, the computers, the network, the application. It doesn't do that, okay? Cybersecurity is where you're going to look into this broader picture of protecting everything, okay? Information security is a practice which only is concerned about the data. It can be user data, it can be consumer data, it can be patient data, etc., okay? So that's basically the difference between cybersecurity. So information security does not constitute or does not contain cybersecurity, but cybersecurity is what actually contains information security within it, okay? So when I talk about data protection measures, I just now mentioned GDPR, which is the data protection regulation within the European Union, which aims to secure user and customer data within the European Union, okay? And when I talk about protection, I mean sensitive data like your credit card information, your name, address, location, and any other confidential information like maybe Aadhaar card numbers, PAN numbers, all those things, right? And it aims to protect that data from unauthorized access and theft, okay? Data leakage. Next is operational security. Operational security includes basically or has the practices for the processes and decisions for handling and protecting data assets, okay? It basically involves user permissions, okay? What sort of user permissions or what sort of permissions a user has when they're accessing the network, and what procedures they are or what procedures are present that can determine as to how and where that data is stored or maybe is shared among that particular network. Okay, so that's basically your operational security. Things like identity management, access control, right? Okay, identity management and data security. So identity management. So when we'll talk about ICE, we'll look at how it manages identity. Okay, how it makes sure that it is context rich and it does management for the identity. It basically involves or includes frameworks and processes that basically enables the AAA framework, which is basically authentication, authorization, right? And accounting as well, obviously. Okay. Then there is the most important thing for an organization, or the weakest point for an organization from a cybersecurity perspective, is the end user. Okay. Irrespective of the fact an organization can spend millions and billions of dollars. Okay, I'll stop here. Bala, you have a question?
Yes. Yeah, I have a question.
Go ahead.
I'm audible?
Yes, you're audible.
Yeah. So I have a very basic questions. I have 2 or 3 questions. I think when you start from the slide 1, so you told CCNP to CCIE, like, okay. So at first, I just want to know who can enroll for this course. I know the cybersecurity means I understand the cybersecurity, and what is the basic qualification required for this course. So I think at first you need to clarify 2 things. Then after I will go the next question.
So I would say anyone who is interested to learn more about security technologies, both from Cisco's perspective and in general, can enroll for this course. Plus, people who have some knowledge, some networking knowledge behind them, something like CCNA, routing and switching, they don't need to have the certification, but if they have the knowledge of how a network basically works, right, they can enroll in this and jumpstart the security journey.
Okay, actually, I was a little afraid because you are mentioning the CCNP and CI, so it's a very high thing. So that's why I'm asking you. And the third question, if I complete, means the after completion, what we can achieve? Like we are able to protect our network, or just we are aware how it works like that. What after completion, what we achieve?
So when we complete this class, okay, thoroughly, so you'll have an in-depth knowledge about these terminologies, okay, the frameworks that go behind cybersecurity, and then you will be able to plan, design, implement various Cisco security technologies that cater to most of these domains. Okay,
means
so
I can implement the same thing, or
right,
the knowledge.
Right. So you'll be able to configure, implement, and optimize. So for example, you may have and already have firewalls installed. The knowledge that you gain from the training, right, you can go back to your organization's firewalls, you can look at them and you can optimize them as well to better protect the organization, right? So this should give you a lot of good information for you to build upon as well.
Okay, got your point. Yeah, yeah, everything is clear. Yeah, please go ahead. Yeah, thank you.
Any other questions?
Nothing for now. If anything, sure, I will ask you.
Okay. Continuing with the end user education. So like I said, end users, the people who are actually the clients, the customers, the consumers within your network, they are the weakest chain, okay? An organization can spend millions and billions of dollars in buying the latest and the greatest technology. They can buy Palo Alto firewalls, Fortinet firewalls, Cisco firewalls. They can buy identity management solutions. They can do everything. But all it takes is an uneducated end user to click a link in an email to have them download some sort of a malware, famously a ransomware, and that can spread within the organization. So end user education is very important. Okay, so building security awareness across the organization is basically key. Okay, so you should strengthen endpoint security, right? If a user or if users' laptops and workstations should not have USBs, you disable USBs, you implement DLP solutions, okay, data loss prevention solutions. You educate them, you train them on how to not or how to recognize suspicious emails and not to click email links and attachments. Okay, so it's very important. 90% of the times, if there is or there has been a breach within an organization, or when you hear that there has been a ransomware attack, it is a user within the organization who clicked on an application or who clicked on some sort of an email attachment or a link within or a link within an email. Okay, it just takes a click. Okay, so end user education is very important, and end users are, like I mentioned, they are the weakest link, they're the weakest chain. Okay, and that's why a lot of cyber attacks, they are centered across, or they are centered for the actual end users. So you might have heard a lot of Paytm, a lot of UPI based attacks. People are getting links on WhatsApp, they try and open it, whatever it's mentioned there, they put in their passcode, and then the money gets transacted from their account, right? So again, end user education and awareness is very important, be it from an organization perspective or be it from a real life day-to-day perspective. Okay, and people who fall for these are old age people or people in the rural areas who do not have much knowledge or who have recently started to use things like digital wallets and digital payments, right? So it's very important. Next is DR and BCP, disaster recovery and business continuity planning. Okay, so every organization should have some tools and procedures for responding to unplanned events. Okay, unplanned events can be things as simple as natural disasters and power outages, right? Floods, okay, or maybe lightning strikes, right? So every organization should have some sort of a disaster recovery in place, okay, and some sort of a BCP plans, okay? And obviously within these natural events, you also have cybersecurity incidents, right? So if an organization gets hit with a ransomware, right, they should have a plan on how their cybersecurity team is going to respond to their ransomware attack, right? What is their team going to do in order to respond? Okay, which you must have seen in a lot of places. It's mentioned as incident response or IR, right? So every organization should have some sort of a plan. Next is your storage security, right? This is basically, so storage can be as simple as the hard drive or the SSD on your laptop or your workstation, okay? This basically includes encryption and immutable and isolated data copies, okay? They can be SANs or NAS on your network or in your data center. So you need to make sure that you have appropriate storage security in place, right? Finally, we have mobile security, right? An organization should have a way to manage and secure the mobile workforce, right? And when I say mobile security, it does not really mention it does not really cater only to mobile phones. Mobile security means mobile workforce, right? They can be users who are working maybe through phones, through tablets, and even people who are coming over VPNs, right? So all of those can be included within mobile security. And then obviously mobile phones are another weak point. So a lot of organizations who allow BYOD or bring your own devices into their organization, they have you install some sort of an MDM solution, which is a mobile device management. through which what they can do is they can control what goes onto your mobile phone. Okay. And if and what those MDM solutions can do is they can segregate your mobile into two virtual instances, right? So you can have a separate instance on that same mobile, which caters to work only, and then another section which only caters to your personal life, right? So there is no interaction between those two, right? So MDM solution is very important. A good example of an MDM solution that is deployed worldwide or in a lot of places is Microsoft's Intune. Okay, so that's basically an MDM device. You can have ICE integrate with MDM solutions to cater to identity management and access control for BYOD solutions. Okay, so that's mobile security. Any questions related to any of this information here before I move on?
Sir, I have one question.
Yeah, sure, go ahead.
Yeah, actually, I'm confused between the information security and the data security.
Information security and data security.
Sure. Because I think information is the data, and so why it is participate that created a partition between two.
You could probably, or from the slide perspective, you could probably think of them as the same thing.
Yeah.
Okay. So when I say information security, which kind of is data protection measures, you can think of it as data security as well.
Yeah, definitely. I'm thinking like, yeah, information security and that data security are similar.
Right.
Yeah. Okay. Thank you.
Any other questions? Okay. So moving on to cyber threats. Now, at a very high level, there can be three types of cyber threats. Okay. One can be a cybercrime, right? Cybercrime basically includes single actors. And when I say actors, I mean hackers. Okay. Single hackers or groups who are basically targeting systems for financial gain. Okay. Or to cause any sort of disruption. Okay. When I say financial gain, this can be things like your ransomware attacks on organization, right? So they encrypt the files and then they ask for ransomware. So that's basically the financial gain that they are trying to accomplish, right? Or they can cause disruption, right? You must have seen or you must have heard Twitter went down, maybe Instagram went down, maybe Facebook went down for half an hour, etc., etc. There was some sort of a denial of service attack. So those are meant to cause disruptions. Okay. You then have cyber attacks. Okay. Cyber attacks are basically politically motivated information gathering, right? So this is basically seen around when we have elections. Okay. Or maybe some sort of a political vendetta when an organization is trying to support and people who are not happy with that, they can probably carry out cyber attacks to, gather the information in those cases, right? Finally, you have what is known as cyber terrorism. Okay. This is basically intended to undermine any sort of electronic systems, right? To cause some sort of a fear or panic. Okay. So currently, you must be seeing some sort of a cyber attack or cyber terrorism going on within the Russian and the Ukrainian war as well, war conflict, right? So Ukrainian cyberspace is trying to do harm to Russian cyberspace as well, as long as they're trying to protect on the ground. Okay, so you could call that cyber terrorism, or you can call it cyber attack as well. Okay. Now, how do these hackers or cyber criminals or cyber attackers are able to gain control of computer systems? Okay, there are some common methods that are used to threaten the cybersecurity of an organization. Okay. First is a malware. Okay, malware is basically short for malicious software. Okay, there are various software variants of malwares. You have viruses, you have Trojans, you have spyware, you have adwares, you have worms. Okay, and we're going to go over all of these in a later slide. But all of these comprise of malware, right? These malwares, they provide unauthorized access or cause damage to a computer network or to a computer system. Okay, the malware attacks, they are now increasing filelessly, and they are designed to get around familiar detection methods. So a lot of times you still see malwares that are attacking or affecting organizations, but are not being picked up by antivirus tools, right? So increasingly nowadays, malwares are being created in such a way that they can circumvent or hide their signatures from antivirus tools. Okay, one of the examples for this is a 0-day vulnerability or a 0-day exploit or a malware, right? So since it's 0-day, none of the big antivirus organizations have any knowledge about the vulnerability or the actual associated malware with it, right? Next is ransomware. Okay, it is a type of malware as well. Okay, this malware basically it encrypts and lockdowns files and data or systems. Okay, and the attackers, they basically threaten to erase or destroy the data if they are not paid a ransom, right? Recent ransomware attacks, they have been targeting a lot of state and local governments as well, right? Which for the most part, they are much easier to breach. State and local government governments, they're much easier to breach than big organizations. And they're also under pressure to pay ransom in order to restore their applications, right? Because those applications and websites are meant for the public and the citizens, right? So they are under a lot of pressure to actually pay the ransom in order to unlock those files and the data or the systems and the network. Next, we have phishing or social engineering. This is what I was talking about when I talked about the end user education or getting links or attachments or malicious links and attachments, emails, right? So this is where your phishing and the social engineering comes into picture, okay? So phishing is a form of social engineering. There are various other social engineering as well. You have wishing, you have smishing, you have whaling, you have water holing attacks, you have things like tailgating, right? So all of these come under social engineering. And I have a separate slide altogether to discuss social engineering. So we'll talk about it in much more detail. Phishing is a form of social engineering that actually tricks the users into providing their own PII or sensitive information, right? If you recall, PII means information like your name, address, maybe credit card information, maybe your address, your date of birth, things like mobile numbers, right? Things like your Aadhaar card number, your PAN number, your passport number, all of these things, they fall under PII or sensitive information. Basically, in phishing, you have emails or text messages which basically appear to come from a legitimate organization or legitimate company, right? And they're asking for some sort of a sensitive information, right? It can also be your login credentials, right? So I can send you an email which looks like it came from Facebook and asking you to reset your password. You click on it, you enter the information, and then that information gets passed on to a malicious actor, right? So now that person has your login credentials. He can go in and log into your actual Facebook account. Okay, so phishing is one of the social engineering attacks. Insider threats, again, this is the end user bit again, right? So within an organization, you can have threats from users who are uneducated, plus insider threats can also be from current or former employees, right? Or maybe business partners or contractors, right? Or anyone who has had access to the systems and the network in the past, okay? They can be considered an insider threat. Now, the condition is that if they abuse their access permissions, right? So maybe, for example, a user or an employee gets fired, right? The organization should remove all their access with immediate effect. If they fail to do so, that malicious, that employee can abuse the access. It can take a pen drive and download some confidential or legal information or intellectual information from the organization, right? It can install malware on their systems, right? So when a good employee kind of becomes a disgruntled employee, they kind of fall into the category of insider threat, okay? Insider threats, obviously, they are invisible to things like your firewalls and your intrusion detection systems, right? Because they are meant to protect any external threats which are trying to come in or access your internal system, right? DOS or DDoS, denial of service or distributed denial of service attacks, okay? Talked about it multiple times already. These attacks are meant to crash a server, a website, or a network by overloading it with traffic, right? DDoS, so the difference between DOS and DDoS is DDoS is distributed. It means that the attack is going to be from various different sources, okay? So you cannot block that attack based upon, let's say, a source address, right? So a distributed denial of service attack can happen from hundreds and thousands of computers or devices on the internet, right? So you cannot go in and create an access list or some sort of a blocking for every single of those source IP addresses, right? So that's basically a distributed denial of service. A denial of service is basically kind of like a one-to-one attack, which is basically coming from a single source and aimed to your organization, to your server, right? So it's kind of like a one-to-one mapping, right? Much easier to block than a distributed denial of service, right? But the purpose is the same. The next threat is an APT, or an advanced persistent threat. So these are basically very sophisticated and very knowledgeable people, right? Or teams or organizations, or I would call them intruders or groups of intruders who basically infiltrate a system and remain undetected for an extended period. Okay, so in the next slide, I've covered a couple of cyber attacks. And in there, I have mentioned a cyber attack in which an organization was attacked. They did not come to know about the attack for like 6 to 7 months. So the people who attacked, they were in the organization. When I say in the organization, I mean they've had access to all the data and all the systems for a period of 6 to 7 months, right? So they could do anything, and they did extract as much data as they could before anyone realized that they already had some sort of information breach. Okay, so APTs basically are those. They hack into systems and they remain in the system undetected for an extended period. Okay, they can leave the network and system intact, right? So that the intruder can spy on the business activities of the organization and steal the sensitive data while avoiding detection from things like your firewalls or your IPSs or IDSs or antivirus systems, right? If you have been current with a lot of organizations, one of the attacks that I was talking about was SolarWinds. Okay, there was a SolarWinds attack that happened recently, which basically is an example of an APT attack, okay, or an APT threat. Last is your MITM, or man-in-the-middle attacks. Okay, so this is basically an eavesdropping attack, which basically I'm trying to send data from A to B, right? And without each of our knowledge, there is someone in the middle who is eavesdropping, who is stealing or who is intercepting that data. Okay, so basically MITM is an eavesdropping attack where a cyber criminal intercepts and relays message between the two parties in order to steal the data. Okay, this can be or it can be an example of maybe an unsecured Wi-Fi network, right? You go into a coffee shop, you turn on the Wi-Fi and you see, hey, there is an unsecured Wi-Fi. You try and connect it, right? It can be someone else sitting on another table with his laptop acting as a Wi-Fi access point, and you connect to it, right? So now that person can run something like a bar shop, right? And maybe you're trying to access a social media network. So when you try to connect to social media, you are entering the password, username and password, and all of that information is going through his laptop, right? So he can capture that information and use it for whatever purpose he needs to. Okay, so that's basically an MITM attack. Any questions on this?
Yes. Hello.
Yes, go ahead.
Yeah. Do we have lab regarding all this, like DOS or DDoS?
We don't have labs specifically for these. So the purpose for having this is to get you familiar with some of these terminologies. Okay.
Okay, but it will be better if we will show like TCP flood attack and then DHCP attack.
So okay, so the course or the class, this class alone, it's going to be close to 110, 120 hours. So, right. And there are lots of labs that we need to do in terms of, and there's a lot of materials that we need to cover for the N number of Cisco technologies that are there. So if we start including these technologies or these labs for that purpose, this course is going to run super long, right? So if you need to have some hands-on about these technologies, I'm pretty sure there are some courses related to ethical hacking with network kings that you can enroll in, right? Which would specifically cover labs around a lot of these things.
Okay, so in this model, I'm lab related topics are.
Lab-related topics are related to your CCNP and CCIE security technologies, your ASAs, firepower, ICE, WSA, ESA, all those things.
Okay, thank you.
Okay.
Oh, sir, I have a question regarding cyber attacks. Like, as you said that it's that attack which happens to that happens between two political parties, and they tend to do this cyber attack. So, like, can you give us an example, like what kind, like cyber terrorism they do through electronic devices, as you said, but any example of cyber attacks, like
Yeah,
how they do that?
Yeah, I have some cyber attacks mentioned on the next slide.
Okay.
So I've put in some examples for a couple of worst cyber attacks that happened quite recently, right? So if I talk about cyber attacks, there can be a whole number of cyber attacks, right? The list can be very long, right? So I've included some recent and notable attacks. So this one happened recently in March. Okay, this was for SolarWinds. So what the hackers did was they break into SolarWinds and they inserted malware into SolarWinds Orion software updater, right? So it's basically a software updater that that SolarWinds uses to push out updates to organizations, right? So the hackers, they actually put malware into this update engine. So when SolarWinds pushed updates, it basically pushed the malware to 18,000 customers. Okay. This basically allowed these attackers to remain in the organization environment for months without being detected. Okay. So you can see how clever the attackers and the cyber criminals can get. Rather than attacking each customer individually or each organization individually, they actually put in the malware into the software update engine. So this is, if you understand it, this is as simple as me putting a malware into Microsoft's update engine. And when you get your new update or next update from Microsoft for Windows 10 or Windows 11, you get malware along with it, right? And neither Microsoft would know, neither you would know, because it is coming from the actual vendor, right? So if a vendor is pushing out software updates, you have very little to suspect in terms of that it is going to be something malicious. Okay, so this was a very recent one. This caused a lot of problems for a lot of organizations because SolarWinds is used in a lot of organizations. This is basically an NMS product, a network management solution product, right? So a lot of organizations, a lot of networks use this. Microsoft Exchange was hacked as well. There is a Chinese hacking group known as Hafnium. They basically were able to find and exploit vulnerabilities in Microsoft Exchange, which gave them access to email accounts of at least 30,000 organizations in US and 250,000 accounts globally. Okay, so an organization as big as Microsoft Exchange, and most of the, or I would say 99% of the organizations out there use some sort of an Microsoft Exchange or MS Outlook and things of those nature, right? So this Chinese hacker group was able to find and exploit vulnerabilities within this, and they were able to get access to a whole lot of database. And this database would have went on for sale on the dark web. Okay. There was a ransomware attack, which they named as Quanta. This was done by the Russian ransomware hacking group REvil. So if you follow any cybersecurity news or anything, a member of REvil, this hacking group, he was arrested or captured, and he has been deported. I would say deported. It has been brought into United States to stand trial for one of the hackings that was done by the group. Okay, and this is basically a ransomware as a service hacking group, right? So this is an RAAS. So what this means is I can approach this ransomware group and say, hey, I want you to hack this particular organization, right? So I will hire them and grab ransomware as a service, right? So these guys do this. So what they did was they actually, so Quanta is basically Apple's supplier, right? So they actually hit them with ransomware, and they asked $50 million as a ransomware or a ransom from them to unlock their systems. So this is a very famous hacking group, REvil. Okay, and you can look at, you can probably Google REvil, and you're going to see a lot of different hackings that they have done in the past. And you should also see information or news about the REvil member who was recently convicted, and he has been flown into United States to stand trial for one of the hackings or cyber crimes or cyber attacks that he did, or he was involved in. This is very recent, very, very recent. If you have been following the Log4j, okay, this is considered to be a super big vulnerability. This happened in December of 2021. So this is a zero-day vulnerability, okay? And when I say zero-day vulnerability, it means that no one knows about it, okay? Or no one knew about it. So that's why a lot of organizations went through this. So this is basically, so any organizations or any program that basically use Apache, right? It uses a Log4j is basically a logging library, right? So anytime you use Apache or anytime you program something, there is some sort of a logging that happens as well, right? So this defect or this vulnerability is within that Log4j open source logging library, right? And this open source logging library, Log4j, is used on 99% of the applications out there, right? Things like Microsoft, Twitter, Amazon, Apple, Netflix, you name it, and they would be using Log4j, okay? So this zero-day vulnerability affected this, and it is super big because you can see how many applications would have been affected, right? Cisco has a number of products that were affected by Log4j, okay? Matt Olney, he's the director of Cisco Talos Threat Intelligence. team, he basically said during a live stream that every organization out there is going to have some exposure to this most likely. Very few will escape. So that's why it has been termed a very big and very recent vulnerability because of the scale and the way that the vulnerability is, okay? So he basically mentioned that almost every organization that is out there on the internet is going to be affected with this vulnerability. Okay, so even in my organization, so we had to put in numerous measures for Log4j because a lot of applications, in-house applications, and a lot of other applications that were being used, things like with Microsoft, right? A lot of Microsoft apps every organization uses, right? So if you use Microsoft, you got vulnerable to Log4j, okay? And it was critical because it could do RCE, okay? So anytime a vulnerability can do or can execute RCE, it is considered a critical vulnerability, okay? So when I say critical, it got a CVSS score of 10, right? So what is RCE? RCE is remote code execution, okay? So I can write some code and I'll send it to your application and I'll be able to execute that code on your application, right? So if a vulnerability allows me to do that, it is considered a critical vulnerability. So always and always, whenever you will see a vulnerability that is able to execute RCE, that is always going to be a critical vulnerability, and it will always have a CVSS of 10.0, which is the highest score that a vulnerability can get. Okay, any questions? And we'll talk about CVSS later on.
Yes, I have a question.
Yes.
What they did through the Log4j? I mean, which type of attack they did?
It's basically an RCE.
No, I didn't get this. Could you please explain again?
It's RCE, remote code execution. So I can send a malicious code to the application, and the application will allow me to execute that code on the application itself. Okay. So for example, if I'm trying to access Microsoft Exchange, right? If I send a code to Microsoft Exchange, it should not allow me to execute my code on it.
Okay, got it.
Right? If I'm not a developer, obviously, if I do not own that application, it should not allow me to do that. Yeah, but if a vulnerability allows me to run any malicious code on itself, it is basically considered an RCE, a remote code execution. Okay. And like I've mentioned, anytime you have an RCE, this is basically going to be a critical vulnerability. That's why there is so much ongoing tension in organizations because of this, because if it's not patched or if it's not fixed for an application, then if a hacker gets access to that application, it can run its own code, steal data, maybe crash the service, maybe crash the server, maybe have it rebooted, etc., etc. So you can do a whole lot of things if you can execute an RCE on an application.
Hey, Arun, this is Surya. So
yes,
do you know any attack where this vulnerability has been exploited? I know this is just a vulnerability, but has anyone used this vulnerability to attack?
Yes, so it has been used across. I mean, I'm not sure from if any of these organizations were affected, right? But it has been used. That's why it's basically mentioned as a cyber attack. Okay, because it did surface. It was attacked, right? Or some organization or a lot of organizations were affected by this, right? So that's why it basically is known as a cyber attack.
Yep. Yeah. Even my organization had this meeting regarding this Log4j because most of our applications are also using this for logging.
Right.
But it was not exploited, so we were able to patch them.
Right.
Yep.
Any other questions?
No.
Okay, let's move on. I've already talked about cybersec and infosec, right? Let's talk a little bit more about it. So as I've already mentioned, cybersecurity is the practice of protecting data, its related technologies and storage sources from threats. Okay, cybersec or cybersecurity aims to protect anything and everything within a cyber realm. Right? It can be data, it can be information, it can be services, it can be devices, and any associated technologies. Okay. Versus information security only aims to protect data and information against unauthorized access. Okay. InfoSec protects the confidentiality, integrity, and availability of the information. Together, this is basically known as a CIA triad. Okay. Now, we have talked about the cybersecurity domains and what all the different things that go into and how you can protect protect your network, protect your mobiles, protect your data, etc., etc. There are some controls for InfoSec as well, right? First one is procedural controls. Okay, these controls basically prevent, detect, and minimize security risks to any physical assets. Okay, when I say physical assets, I mean computer systems, data centers, and even they can be things like your cabinets, right? Your filing cabinets in companies, right? So they can include security awareness training for users, education, compliance trainings, and your IR response plans, right? Basically your incident response plans. So that's basically procedural controls. Next, you have access controls, right? Now, as the name suggests, these controls basically dictate on who's allowed to access and use the company information and the company network, right? They also basically control any physical access to the buildings, right? And maybe virtual access, okay? So your badges, right? And all of those things, they fall, or maybe some organizations might have biometric systems, right? Retinal scans, iris scans, okay? All of those things, they fall under your access control, right? It can be as simple as the security guards that are basically the first layer of protection for your buildings, your organization, right? So they are also a form of access control, right? They can deny access if you don't show them your ID cards. Okay, so they can also, or they also fall under access control. Third is your technical controls, right? These are things like your firewalls, your antivirus softwares, your endpoint protection softwares, IDSs and IPSs. Okay, so technical controls. If you have implemented multi-factor authentication at logging, that also falls under technical controls, right? They some examples of MFA could be Cisco's Duo. They can be Okta, right? So all of these, they fall under the technical controls category. Next is your compliance controls. Okay, so these controls, they deal with privacy laws and cybersecurity standards designed to minimize security threats. Okay, again, these are going to be basically your different frameworks. Okay, these are going to be your different frameworks, right? Things like I talked about NIST, right? Then it can be something like COBIT. Okay, or HIPAA, or they can be your PCI DSS, or it can be GDPR, right? So within information security, you have compliance controls that basically cater to this. And it can also involve things like your risk assessment. Okay. And how do you enforce controls to minimize this risk? Okay. Okay, moving on. CIA triad. We'll talk about the CIA triad next. It is very important. It basically, like I've mentioned, it talks about the confidentiality, integrity, and availability of the data. Okay, which is what comprises for your information security. Okay. Security of an organization starts with 3 principles: the CIA, confidentiality, integrity, and availability. This is called the CIA, which has served as the industry standard for computer security since the time of first mainframes, or the mainframe computers, right? So this is what it kind of looks like. Okay, so first we'll kind of talk about confidentiality, or let's just talk about all 3 of these right here. So first is confidentiality. So confidentiality basically it involves, or it's basically an organization efforts to make sure that the data is kept private, or the data is kept secret, right? To accomplish this, we have to control the access to the information, right? So that unauthorized sharing of data and access of data, which can be intentionally, or it can be maybe accidentally, right? Human error, right? It does not happen. A key component to maintaining the confidentiality is to make sure that people with improper authorization are prevented, right? So basically, you follow the principle of least privilege. Okay, least privilege. So if a user should not have access, or a user should only have access, okay, so let me reterm this. So you should only give access to a user depending upon its role. So the security engineers or the admins can have an access to the whole system, right? Because they are going to run maintenance, upgrades, etc., configuration for the system. But an end user should not have an admin access, right? If he is an end user and only needs to check maybe his email or something on a system, then all he needs to have access is to maybe Outlook and nothing else, right? Similarly, if it's a security analyst, right, and he's trying to log into a Windows machine or maybe a logging system, right? So being a security analyst, he should not have access, or he should not be able to write anything, right? He should not have write privileges, right? Being a security analyst, he only needs to be able to read the logs, analyze the logs. So he only should have read access, right? So always follow the principle of least privilege. Okay. Now, again, like I mentioned, and I'll give you an example. Another example would be, maybe let's say an organization finances, right? People who work, or maybe in an organization, people who are part of the finance team, they are the only ones who should have access to the spreadsheets and the bank accounts and other information related to the flow of money, right? To and from the organization. Other employees, and it could even involve some executives who should not have that knowledge. They should not be granted access, irrespective of the fact, even if they are executives, right? there are several ways in which confidentiality can be compromised. Okay, it can involve direct attacks to the system, right? Where the attacker does not have the rights to see what it needs to. Similarly, right, what I was talking, he does not have read and write access, but he can still try to access a system, maybe a PC or a server, right? It can also involve an attacker who's trying to make an attempt, right, to the application or the database to maybe exfiltrate the data, right, or alter the data or modify the data. Okay. A common attack, which I have already shown you, is MITM, right? You're sitting here trying to transfer data to someone else. I come in the middle, I put in my PC, and I start grabbing this data, right? So this is a breach of confidentiality, because what was meant to be sent between A and B, I can view it on my machine, right? So this is basically a confidentiality breach. How do you circumvent confidentiality and make sure the data is confidential? And when I talk about data confidentiality, it involves to both data in transit and data at rest. Okay, so very important. Data is transit, so this would be transit data. Data is at rest would be data in storage, right? Your laptops, computers, having HDD, having SSD, right? So how do you enforce confidentiality? To encryption. Okay, using algorithms like DES, triple DES, AES. Okay, so if I encrypt this data with, let's say, AES, right, I can be sitting here as much as I want. All of this data that I capture is going to be gibberish, right? I won't be able to make any sense because the data is encrypted. Only A and B have what it takes to decrypt that data. Okay. Similarly, with data at rest, you can encrypt your storage, your hard drive, your SSD. So if you're on Windows, you have the option to do BitLocker encryption, right? Which encrypts your hard drives. If you're on a Mac, I believe it is called Firewall, right? So encryption, so anytime anyone tells you, hey, what do I do to maintain confidentiality? Your answer should be, hey, you encrypt the data, whether it's in transit or whether it's at rest, right? You do encryption. So these are some of the encryption algorithms. You don't use these anymore because they are weak. AES, or Advanced Encryption Standard, is the more or the most secure up until now. Okay, so most of the places you'll see AES being used. Okay. Another bit for confidentiality is you can implement MFA, or multi-factor authorization, right? You can implement MFA, right? Or two-factor authentication, right? Two-factor authentication. So user enters his username and password. Okay. He then needs to put another passcode from an application, right? It can be, like I said, it can be something like Cisco Duo. It can be your Google authenticator. It can be Microsoft's authenticator, right? Or it can be something like an Okta. Okay, so once he enters this password into the application, only then he gets access. Okay, so that's how you preserve, or you have confidentiality. Okay, Now, what is integrity? Integrity means data remains unaltered or unmodified. Okay, that is integrity. Okay, so for example, if I have A and B, right? So I'm sending a packet with ABC. When B receives it, it should be A, B, and C, right? Now, if this packet that's received here, it's A, B, and C, notice the difference in the uppercase and lowercase, right? So if that's the difference, then this means that the integrity has been breached. Okay, that the data is no longer what it was supposed to be, and what it was supposed to be at the source. It's not what it was delivered on destination. And how an application can check for data integrity is through hashing. Okay, hashing algorithms are MD5, message digest, or SHA, right? You have SHA-1, SHA-2. So what you do with these hashing algorithms, you take this packet, right? You run it through a hashing algorithm and you get an output, right? Now this output can be anything. Okay. You add this to the data packet and you send it. When B receives this data, it runs this through the same algorithm that you used at the source. And if it comes to the same value, that means that the data is fine, right? But in this case, if it's a change, you would see a different value. It means that the data integrity was breached. Okay, if you would have noticed, a lot of times when you download, or if you have downloaded software from Cisco's website, Cisco gives you a couple of values for softwares. They give you a SHA-1 sum, they give you an MD5 sum for all their files, right? Now the purpose for that is once you download that file, maybe you download an iOS, right? You calculate the SHA value, right? And there are applications that can do that, right? On Windows, if you're on Linux or Mac, there is an inbuilt utility that can calculate. So you run this file against the algorithm and you calculate a value. You can go back to Cisco's website and match the value. If both of these values match, then your download was good. Okay. If these values don't match, then it means that someone or something altered the contents of the file and the integrity of the file was breached. So you either re-download the file, right? And you calculate this again to make sure that the file integrity is maintained. Okay. So anytime anyone asks you or you're discussing about data integrity, how do you achieve, or how do you know that the data is still in its entirety or it has not been altered? You do hashing, or you run this through an hashing algorithm. Okay, so remember, a file, if it runs through an algorithm, and it can be n number of times, it will always give the same hash value, always. Okay. Another file run through the same value should not give the same value as I saw for A. Okay. So two different files should not give the same hash value. If that happens, then that is known as hash collision. Okay, and this is a serious problem. That's why we do not use MD5 nowadays, because with MD5, what a hacker can do is, if you have a file and you run it through MD5 and you come to a hash value, he can run a completely different file through MD5 and get the same hash value, right? So he can trick you into thinking that you are actually trying to access file A when you're actually trying to access a complete different file. Okay, so SHA-1 is also not recommended now. Okay, SHA-2 family is the recommended hashing algorithm that should be used across organizations. Any questions with confidentiality and integrity before I move to availability?
Yes, I do have. But what did it mean by 3DS? It means 3 times strength, or 3 times it will encrypt. I mean,
so
3 times it will do in encrypt.
yeah, so we had an algorithm earlier on which was DES, right? This was not strong enough, so what the creators did was they said, hey, run the DES 3 times. Okay, so run this algorithm on a data thrice. So that's when they came up with 3 DES. Or
no, it will encrypt 3 times, or it is the strength of 3 times?
Right, we kind of encrypt, or we run, so we run DES, we come up with some sort of an encrypted data, we run DES again on that same encrypted data, and then we run DES again on that encrypted data.
Okay.
So we run it thrice.
Understood.
Okay.
Yeah.
Any other question?
Oh, no. Thank you.
Yes.
I have one question. Is hashing also, can hashing also be used for confidentiality? Like if I stored hashed password, nobody is going to be able to see that password unless they reverse run through the same hash function and provide the input. The key.
So encryption and hashing are 2 different things.
Okay.
So when I encrypt something, so when I encrypt this data, I run it through AES, I'll get something completely different within the payload. So I might get something like, okay, so this is encrypted data. Okay, if I run ABC through a hash algorithm, my data remains as it is. Okay, this produces a value which I can send along with the data, along with the payload. So my payload remains the same with hashing. Okay, the only purpose of hashing is to make sure that this payload remains the way that it is. The way that it was packaged on the source, it is as it is when it was received on the destination. Okay, so that's the difference between encryption and hashing. They're not the same. Hashing alters the payload. So when you hash your when you hash your name through an encryption algorithm, you won't be able to read it correctly because it will be all gibberish. But if you run your name through a hash algorithm, you'll be able to read your name, but you'll also see a value along with it, which basically tells, hey, this is what the value is when the data was packaged at the source. Now, when I receive this data on the destination, I'll take this payload and I'll run this again through SHA-2. Right? So since the data is the same, I will return, or it will return me the same hash value, and it will be a confirmation that the data was not changed or not altered or not modified in transit. Make sense?
Yep.
Okay. Now, availability. So availability is whatever data, whatever services are, right? They are available. They meet SLAs, right? Now, SLAs can be, you have 99.9% SLAs, you have 99.99% SLAs, you have 99.999% SLAs, you have 99.9999% SLAs. So yes, these are different SLAs, okay, for a lot of different services. So availability means that I need to make sure that my servers, my websites, my data that my users are trying to access, they are available to them, right? How do I achieve availability is through having a high availability. So maybe I have my web server or Apache server, right? I can have two of them. I can have one as active, another one as standby, right? So if this fails, this becomes the new active. So there is availability of the server or of the data on this server. Okay. I can also have active, right? I can have both the servers active. What it can do is it can do load balancing then. Okay. So the availability aspect, or with availability, I basically mean that I need to keep my servers up and running. I need to make sure that my services are up and running, right? I either do HA of my servers, right? Maybe have 2 or even 3 of them if I suspect that they might go down, okay? Or I can have active load balancing. So this helps to protect a little bit from DDoS attacks, denial of service attacks. So like I said, denial of service attacks are attacks coming from a lot of different IP addresses, right? They can be hundreds and thousands of IP addresses that are trying to send packets, right? They can be ICMPs, they can be SYN packets, right, to these servers. Now, if it would have been a single server, then this server would have got overwhelmed very quickly. If I have 2 servers active, or maybe have 5 servers, all actives, right? And I have some sort of a load balancing mechanism. Maybe I have an F5 device, or maybe any other load balancer, or maybe I have any other mechanism by which I can send data to. So what I aim to do is not a single server will be overwhelmed with these requests, right? So some traffic will be sent here, some will be sent here, here. So the only point here is that I am just delaying the failure. Okay. If a single server would have gone down in like 10 minutes, or my entire website would have been down like 10 minutes if I would have only had a single server. If I have 5 servers, all actives, this time would probably increase to 1 hour. In this 1 hour, I would have time to do some sort of an incident response. Maybe talk to my ISP and block IP addresses. Okay. So this is another reason why you might want to have some sort of a active scenario where you're doing some sort of a load balancing, right? So that traffic can be load balanced and not a single server is going to take all the load time. Okay. So confidentiality, like I already told you, right? So suppose there's a packet, hello Alice, which Bob is trying to send, he encrypts it and it becomes something like this, right? So this is an encrypted packet. It sends to Alice, who then decrypts this packet, right? And is then able to see the contents, okay? So if you're not sure what the secret key is kind of doing, then you can probably ignore it for now. I'm going to talk a little bit about this and it in more detail when we'll talk about cryptography and PKI. Okay, so basically, there's a secret key which Bob used to encrypt this data. And this secret key can then be used by Alice to decrypt this data. Okay. No one else will be able to decrypt this data if he does not have the secret key. Okay, so that's the only purpose of having the secret key. So depending upon how the secret key is and how it's shared, it can be asymmetrical or it can be symmetrical. Okay, so not going into too much details now, but we'll talk about this in more detail when we talk about or when we go over cryptography. Okay, so again, the purpose of confidentiality here is we are trying to encrypt the data. We are trying to protect, or we are trying to keep the data secret or private. Only the person who is supposed to receive the data and see the data should be able to decrypt the data and see it. No one else or everyone else should just see this data as a gibberish piece of information. Integrity. Like I said, you take some piece of information input, you run it through a hash function, right? This can be your MD5, this can be SHA-1, can be SHA-2, and you get a digest value, you get a hash value, okay? This is not the actual payload. This is the actual hash value. You send, you would have Fox, and then you will have the digest value sent along with it. Okay. And when this data will be received at the other end, the destination will run Fox against the same hash function. And come up with a value, which will be digest. If this digest that was received matches the digest that was calculated on the destination, then it means that the data has not been altered or modified in transit. Okay. Last, we talked about the availability bit, and I already talked about the denial of service attack. Okay, that how there can be a large number of devices on the internet, which basically are considered to be zombies. Okay, which are functioning under the control of their handlers. These are basically known as CNC servers. Okay, command and control. So an attacker will be sending instructions to this CNC server, and these CNC servers will be sending the instructions to these zombies or PCs. So these can be PCs, these can be printers, these can be IoT devices, you know, they can be any number of devices. These are sometimes called as zombies, right? Because they don't have a brain of their own, right? Whatever is being told by the CNC server, that's what they are doing. That's why they're called zombies, right? Or they can be also called as bots, right? And a group of these which are attacking, they are known as botnets. Okay, so two different terminologies that you can or you might come across. Okay, any questions before we move on regarding the CIA triad? It's a very important concept. It's going to be very useful, you know, when we discuss about VPN, we're going to see encryption coming into picture, we're going to see hashing coming into picture. Okay. And then when we talk about the different devices, right, firewalls, etc., we're going to look at high availability. So it's a very good foundation to understand that why they are there and what they are meant to do. Okay, so no more questions. So I'll probably then move on. Okay, so let's talk about some best practices in general for cybersecurity. Okay, like I've already mentioned, the very first one is conduct your trainings and have ample amount of awareness within your organization. Right, your end users should know and should be able to differentiate a malicious email from a legitimate email. Okay, and it's very basic. They don't even need to be super technical, and you should be able to enforce them to not click links and attachments every time they see one on an email, even if they think that it's legitimate. Okay, so this is a very strong cybersecurity strategy, right? That's why I've put up as the number one, because like I've mentioned, end users are the least or are the weakest chain in cybersecurity. Okay, so educating the employees and raising awareness of the company policies, right? You could conduct webinars, you could conduct seminars, you could conduct Q&A sessions with your cybersecurity team and professionals. You can have them sign up for online courses that go over cybersecurity best practices. So make sure that organizations are doing that. They are going through trainings, right? My organization does that for us. We regularly, every year, we do annual trainings, right? We do run email campaigns, which are simulated emails being sent to mailboxes. And then if you click on it, then you get a kind of like a training link that, hey, you need to repeat the training. This would have been a malicious link that you clicked, right? So you can run email campaigns as well. Next would be to perform risk assessments, right? Every organization should perform a formal risk assessment, right? What the risk assessment does, and we'll talk about risk assessment in detail when we talk about risks, is to identify all valuable assets, right? They can be paperworks, files, file cabinets being stored, computers, PCs, data centers, etc., right? So valuable assets, and they need to prioritize them, right? Based upon the impact if a particular asset gets compromised, right? So let's say a file gets stolen. What is going to be the risk if a file gets breached, right? Or if it gets stolen for the organization? So they need to be aware, right? What it does is it will then help the organization to decide which assets are valuable and on which of those assets they would need to spend money to get the resources to protect them. Okay, maybe get better file cabinets, maybe put up a different room altogether with biometric systems and have only limited number of people have access to that room which has all those files, right? So it kind of gives the company or an organization a head start, right? To help them decide on how to best spend their resources on securing each of those valuable resources. Okay, so it's very important for every organization to perform a formal risk analysis or assessment annually. Vulnerability management and software patch management and updates, again, very important. And this is not just for organizations, this is for us as individuals as well. People do not usually patch their mobile phones, their personal devices, their personal computers, their personal laptops, right? Which opens them up for targeted attacks, right? Even at individual levels, right? And within an organizations, the IT teams should be able to perform identification, classification, okay, of vulnerabilities within all the softwares and the networks, okay? And then in general, the security researchers and attackers should be able to identify new vulnerabilities, right? so that the risk of zero-day exploits can be reduced. Okay, so it's very important for all the IT systems to be kept up to date. This really helps protect the organization's assets. Okay, so I've already talked about principle of least privilege. Okay, both your software and personnels, or your individuals or users or clients, should be allotted the least amount of permissions necessary. Okay, this really. Okay, so going over this again. So the next cybersecurity best practice is to implement a robust business continuity and incident response plan. Having a solid BCIR plans and policies in place, it does really help an organization effectively respond to cyber attacks and any security breaches, thereby also ensuring that any of their critical systems and assets which are supposed to stay online, they remain online. And this is where the risk assessment part comes into picture. If an organization does annual effective risk assessments, then they can gauge what are their critical assets that either need to be online or those need to be protected. So when they implement a BCIR plan, they can focus more so around these critical assets and the business critical systems. Next, another important thing is to perform periodic security reviews. Okay, security reviews means that you do all the software and all the networks. Basically, they go through annual or maybe semi-annual security reviews, which can help identify security issues early on. Okay, security reviews can include things like your penetration testing, right? Application and network, both. Nowadays, it's cloud as well. And then doing source code reviews for any of the maybe in-house applications, design reviews, architecture design reviews, maybe for your enterprise or for your campus or maybe for your data center, right? And red team assessments, right? It kind of is the same thing as penetration testing, right? You do vulnerability assessments, etc. So what does these periodic security reviews help with is they help to find any security vulnerabilities, right? And if an organization proactively is able to identify vulnerabilities within their network or within their applications, they can or they should prioritize and mitigate them as soon as possible, right? Usually, which is done through software upgrades, hard patches, or maybe making some configuration changes on their devices and on their applications. Okay. Next is backing up data, right? There should be periodical data backups that should run, which do increase redundancy and which do make sure or do ensure that all this sensitive data is basically not lost or compromised after a security breach. This is usually really very helpful in case of ransomware attacks, right? So if an organization has a good data backup policy in place and they are doing backups to some sort of an offline site, or maybe they have offline database of their backups, then if they get hit by ransomware, they don't really need to pay the ransom to get the data unlocked and everything. They can just cut off their network, right? Take down the machines that have been affected with ransomware, re-image them, and then put a fresh or restore a fresh backup copy, right? So it's very helpful in case of ransomware attacks. And most organizations, they fail to have a good data backup plan in place. So when they get hit with ransomware, they either have to pay the ransom to get their data back, or if they don't want to do that, then they kind of lose their data, and which increases the actual data theft, money loss that the organization has to go through. Okay. So data backup, it really helps protect in such cases. And even for individuals, right? People like us, Even if you kind of anytime get hit with ransomware, then if you are doing backups, maybe to OneDrive, or maybe if you're using Mac or something to an iCloud or something similar, then you basically can just re-image your laptop or your machine and restore the backup. And that's all that you need to do, okay? Using encryption for data at rest and in transit, like I've already covered in the CIA triad, that you need or you need to maintain data confidentiality, right? That means the data needs to be kept private. It needs to be kept secret. How do you do that? Is through encryption, right? So all sensitive information should be stored and transferred using strong encryption algorithms. And I did mention when I was talking about confidentiality that you have AES as a strong encryption standard currently. Previously, people used to use either DES or triple DES for that purpose, right? So don't recommend using these now. AES is kind of like the standard now, whether you are doing it on Wi-Fi or wireless networks, or you are trying to do on the wired network, right? So AES is kind of like the recommended standard nowadays. Okay, so like I've said, encrypting data ensures confidentiality, right? And then when we will talk about PKI, I'll discuss the importance of keys that help with encryption. Okay, so when you have these keys, then, and if you're using encryption, then it is very important for you to be able to effectively manage these keys, right? So these keys should be kept or should be stored safely. Okay, again, these are digital keys and not physical keys. Okay, they should be kept a secret, and they should be protected. And an organization should have an effective key management and rotation policies. Okay, so maybe you do encryption using maybe some sort of a symmetric algorithm, right? So you have a secret key, right? Now you need to have some sort of a way in which no one can access this secret key. Only some people, administrators, engineers, architects only, who are directly responsible for working with the encryption bit. And then you can have a rotation policy as well, which says that you're going to have a new key maybe at maybe 90 days, every 90 days, right? Or maybe every 180 days. Okay. And in addition to the data on your hard disk, or maybe data that is traveling on the network, or maybe going over the internet, or maybe you're trying to connect from your main data center site to maybe a remote site. So you have a VPN, which again should be encrypted to have the confidentiality in place. And then all the web applications and software should use TLS. Right? Previously, it was called SSL. So usually people use these interchangeably, but they are kind of like the same thing. Okay, so you either call it SSL or either call it TLS, is one and the same thing. But calling it TLS is right. Okay, so this is the current modern standard. SSL is not recommended nowadays. Okay, so web applications and everything should use HTTPS rather than HTTP. Next is your design software and networks with security in mind. Okay, so if you are kind of like a software development organization, or you write your own software, or you have your own in-house applications, right? So when creating these applications or writing software or even architecting networks, right, they should always be, or it should always be done with security in mind. Okay, so the first priority should always be given to security. So it should never be the last priority. Okay, usually when developers are writing code, or maybe designing the software, or maybe even doing architecture design or network design, security is always kept as the last thing, right? But security should always be the first thing in mind. your software design, your application design, your network architecting, your network design should always revolve around security. Okay, you should always make sure that security is always in place. Okay, always bear in mind that the cost of creating the software and everything and adding security measures later on, right, is going to cost you a lot more than if you put security right from the start. Okay, so let's say if you created an application that is maybe vulnerable to some attack or maybe some vulnerability, if it gets attacked and you lose a lot of customer data, you lose a lot of intellectual data, if you lose a lot of company confidential information, then that cost is going to be very high, right? It is going to cost you a lot more to circumvent that or to come out of that situation, right? So putting security early on, surely it might add up to the cost for your software and everything, but it always is really worth it. Okay, so and also security design application, they really help reduce the threats and ensure that maybe when the software really fails or a network fails, they usually fail safely and they do not really open up any grounds for any hackers or any attackers to be actually able to exfiltrate any data or do any data breaches. Okay, so the last one is implement strong input validation and industry standards in security, in secure coding. Okay, so this is primarily related to application development. Okay, input validation is when you maybe open up a website, right, and you need to enter your username and password. This data is user input, right? And this data, it gets passed on to the application. And from that application, it gets passed to the database in the backend, right? Obviously, I mean, how are they then going to validate your username and password? It needs to match against a database, right? So any data that a user is supplying to the application, it should always be validated by the application before processing it or before sending it out to the database. Okay, this is basically application's first line of defense. If not done correctly, this opens up issues such as SQL injection attacks. Okay, cross-site scripting. Okay, so a strong input validation is the first line of defense against various types of injection attacks, right? So softwares and applications, like I mentioned, they are designed to accept user input, okay, which opens them up for a lot of different attacks, right? So any malicious user input, it should always be filtered by the application. So if I'm entering a username and password, I should only be able to put in a username and password and pass it on, right? The username, if the database does not have, let's say, number-based usernames, and if I put in a number in the username, the application should reject this user input, right? So it's really a good practice for developers to have strong input validation in place so that any user input is actually, or any malicious input is basically filtered out before that user input is passed on to the application. Okay. And people usually use SDLC, okay, software development lifecycle. So it basically governs or defines the actual steps or what needs to be done at every single phase, right? So what needs to be done in the design phase, what needs to be done in maybe the coding phase, what needs to be done in the testing phase, and then what needs to be done when the application is actually rolled out. Okay, so these are kind of like your 11 high-level cybersecurity best practices. They're kind of very generic and not just only something that applies to Cisco in general, but it applies generally to cybersecurity realm as a whole. Okay, moving on to some cybersecurity frameworks. Okay, so there are a good number in here, but I'll only discuss some of those in a little detail. Okay, so some of the notable cybersecurity frameworks are, so one of them is Center for Internet Security Controls. Okay, then you have COBIT, like I mentioned earlier on. So there are COBIT certifications as well. There is an organization by the name of that defines. Okay, this is the organization that defines the COBIT framework. This is also the organization that does your CISM, CISA certifications, okay, for cybersecurity. So COBIT also, you would also see certifications like TOGAF coming from COBIT, okay. You next have ISO standard, International Office of Standardization, 27001. So this is kind of like a global standard. A lot of organizations outside of United States kind of adopt this. Okay, this basically defines the framework for establishing what is known as an ISMS. Okay, Information Security Management System. Okay, so this is what the ISO 27001 certification does. So they do certifications for enterprises. So you must have seen a lot of organizations saying, hey, our organization is ISO something something number certified, right? So they do certification, they do audits for organization and see if they have an ISMS system in place and if it is designed the way that they define the framework as. Okay, and if you pass, you get the certification. They also do individual certifications. So a notable one is 27001, I guess, LA, which is a lead auditor. Okay, so an individual like myself can take the certification and then I can do audits for such organizations and make sure that they are in compliance with the ISO 27001 certification. Next is the MITRE ATT&CK framework. Okay, this is kind of like a very popular framework in cybersecurity. Okay, this basically has a lot of information documented around cybersecurity tactics, techniques. So basically what they call it as TTPs, okay, which is your tactics, techniques, and procedures. Okay, and these are the TTPs for cybersecurity attacks, right? So they basically define that if there has been an attack, what sort of a technique, what sort of a tactic did that use? Was it an obfuscation? Was it an evasion technique, right? Was it maybe a bad authentication technique? All sort of things. So they kind of define these TTPs, they kind of document those TTPs, okay? So if I remember correctly, they have like 14 tactics that they have broken down into a lot of different categories, right? A couple of them that I remember is reconnaissance. You have execution. You have privilege escalation. Okay, then you have things like discovery, command and control, CNC, exfiltration. Right, so they define the attacks based upon these tactics or these techniques, right? And they don't really do this only for wired systems. I mean, not only for networks, they also do this for mobile devices, right? So they have a mobile device matrix as well. So a lot of organizations adopt MITRE ATT&CK to see how well they are doing as far as their cybersecurity focus, research, and development is based. Okay. I already talked about NIST in the beginning, which is the National Institute of Technologies, CSF, cybersecurity frameworks. So these guys, they do, so their documentations are called SPs. Which are special publications, okay? So they usually start with special publication 800 dash and some number, depending upon whether it's related to maybe network security, maybe it's related to mobile security, right? Maybe it's related to endpoint security. So they kind of define the framework and how do you need to design your network and have these products in place to have us a more secure organization. So this is mostly based in United States. So it's basically United based. So in the United States, organizations use NIST to design and develop their cybersecurity architecture. But to be honest, this can be used anywhere, right? I've seen a lot of organizations in India use it. Okay. I myself, like I mentioned previously as well, if I am trying to see how I need to maybe design something, maybe there is something that, I'm not aware of, it really comes up and I like to see how I can meet compliance and still design a secure network. I usually consult these NIST special publication documents. Okay, you don't need to learn them, okay, but you need to just be aware that something like this is out there. They usually start with the special publication 800 number, and then they have kind of like a suffix number here as well, depending upon what you are or what do you want. Next is your PCIe DSS. This is the payment card industry. So a little information about this. So this is quite recent. This was founded in 2006. Okay, so this is not really old, and this was basically created because of the increase in credit card frauds. Okay, this is basically not really a compliance. So basically, when I say compliance, this is really a compliance, but they don't penalize. So if an organization deals with credit cards data and the customer data, they can use PCIS to see how can they develop or how can they network their organization better to handle that data, right? But if they fail to do so, they are not penalized, right? So they won't be charged or they won't be held guilty for all of those things. Okay, so they don't do that. But things like HIPAA, right, it penalizes if patient records are breached. GDPR, it kind of penalizes, right? You get jail time, you have to pay money. Okay, so PCI DSS does not do that. So this is basically comprised, or the PCI DSS, I would say, council is comprised of 5 major credit card companies, okay, which is basically your American Express. Then you have Discover, right? So Discover is mostly in the US, I believe. You have JCB International. And then obviously you have MasterCard and Visa. Okay, so these 5 guys, they comprise the PCI DSS Council. They have different categories, which basically they line out things like installing and configuring firewall, right? They do mention that you should not use default configurations. including passwords or any other thing on the devices that you use when you're trying to deal with customer or credit card data. Okay, so this is specifically for organizations, financial institutions that deal with credit card data. Okay, so things like your Amazon, your Netflix, and all these things who have some sort of a credit card information that you pass on to them. Okay, so they kind of use PCI DSS to make sure they are protecting the credit card information. Okay, things like encryption, okay, encrypt the credit card data holders. Okay, they need to protect all the systems against malware. Okay, they also mention that if there has to be a change, maybe a configuration change on any firewall or any device for that matter, then the organization needs to run a vulnerability assessment every time. Okay, so this is one of the things that PCI DSS mentions. Okay, so every time you make a change on a firewall or any other device, you should run a vulnerability assessment to make sure that that configuration change did not open up any new vulnerability. Okay, they also do mention things to protect the kiosks. Okay, public kiosks, on how the data from the kiosks and everything is mentioned. I believe they do for the kiosks as well. Okay, so these are some of them. They have 14, no 14. They are basically 12 detailed outlines that they do. I only mention a couple of them here, but you get the point basically. Okay, of why this PCI DSS compliance is in place. Okay, next is your HIPAA, which is the Health Insurance Portability and Accountability Act. Okay, so I'll talk about this in a little bit, not too much in detail, right? Because we really don't have HIPAA in India, but you should at least know what HIPAA basically is or what it governs. So HIPAA basically protects PHI data, okay, which is basically, or I should say, they are patient records, right? So this includes things like patient's name, their address, date of birth. If you're in the US, they have social security numbers or SSNs, okay? Any biometric identifiers. When I say biometric identifiers, they can be fingerprints, they can be retina information, they can be iris information or iris information. Okay, so, and PHI also mentions any personal PII data. Okay, so all of this data consists of PHI. Okay, and any healthcare organization which has this data, they need to be compliant with the HIPAA Act. Okay, so any sort of medical record basically gets HIPAA. Okay, it's obviously more there in US. It's there in the UK as well. So a lot of these organizations, they kind of have these countries really have HIPAA. Now, the good thing about HIPAA is that if I, as a patient, my data gets stolen or the PHI gets stolen, then there are some penalties which HIPAA imposes on the organization. Okay, so this is under HIPAA's privacy rule. Okay, so there are 4 different categories depending upon how severe the breach is. Okay, so basically, if the breach is unknown, by that I mean the healthcare organization, they by accident leaked some information, right? So that organization gets penalized $100 per violation. Okay, and the maximum limit is $25,000 US. So that's the maximum that can be penalized under this severity. Okay, next is if there is a reasonable cause, if there's a reasonable cause for the violation, okay, then this penalty gets increased 10 times. It's $1,000 per violation. Okay, and the maximum that the organization can be penalized is $100,000. That's the maximum. Okay, now the most severe are these two. So the third one is that it was, or there was a significant neglect from the organization. Okay, but the violation was corrected, right? Within a given time frame. Okay, so let's say HIPAA says that if there was a neglect and you willfully did the violation, but let's say you have maybe a week of time and you're able to correct that violation. Okay, so the penalty in this case is $1,000 per violation. Okay, and the maximum that can be charged is, and this is annually. Okay, the last one is there was neglect and the violation was not corrected. Okay, so this is the most severe of it. So the organization gets charged $50,000 per violation. Okay, and they can be charged with a maximum of $1.5 million per year. Okay, so this is basically HIPAA's privacy rule, where if the customer data is stolen, right, the organization, depending upon how severe the situation is, HIPAA Act involves these penalties. Okay, and there is another rule under this, another thing under this privacy rule is that if the privacy rule is violated, you know, maybe with false information or maybe with false pretenses or something, these penalties, they can be increased to $1 lakh fine and 10 years of jail time. Okay, and this is usually given to executives. Okay, so maybe it's a hospital, maybe it's a clinic, whoever the owners are, or the board of group, the board members are, etc. Those are the ones who actually get involved in the jail time, usually. Okay, so that's basically the HIPAA Act. Another one that I really like is GDPR, European Union General Data Protection Regulation. Okay, so this basically, like the name suggests, it's for all members of the European Union. Okay, all member countries that are within the European Union, and they are dealing with any sort of consumer and customer data, they have to comply with GDPR. Okay, and if you are not from European Union, but you are still doing business in European Union, okay, you need to still comply with GDPR. Okay, so maybe let's say you have, or you are based in India, but you have a website or some business that you deal with European Union countries, and you still get the data, or you store the data from European Union customers, you are, and you need to comply with GDPR. Okay, if you don't, then usually, obviously, there are penalties, and then your website or your business will be completely shut down within the European Union. Okay, there have been cases in the past for this. Okay, there have been some websites. I think it was US based couple of organizations. One was Chicago Tribune and another one was LA Times. They are banned in European Union because they fail to comply with European GDPR rules. Okay. Now, talking about the fines, if an organization dealing in European Union fails to comply with GDPR, then they can be fined 2% or 4% of their total annual turnover. Okay. Or it can be 10 million or 20 million euros. This is usually whichever is greater. Okay. So if this 2% or 4% of your total annual turnover is greater, then you will pay this. Otherwise, you will pay either 10 million or 20 million euros. Okay, in fines. Okay. So it basically, if your organization is collects any regulated data from European users, then you are liable and you have to comply with GDPR. Okay, so those were your frameworks. Any questions on this?
Yes, Arun. How would this information would be helpful for us while creating any configuration or anything on the device? So how would this information would be helpful for us?
Right. So if you are maybe with a financial institution, then you need to look into PCI DSS and see what they do say. Right. What does the framework say when you're trying to design a network within a financial institution? If you are working for a healthcare organizations, like I work for a Fortune 500 healthcare organization, I need to make sure that I am compliant with whatever I do with HIPAA. Right. And if you are dealing with customers or designing network or security solution for a European Union country organization, maybe, right? Then you need to make sure that the way that the data is protected, right? It complies with GDPR.
And is there any tools that that we can use to make sure that we are complying with the actual frameworks?
I'm sorry, didn't get the question.
Is there any tools which can check the compliance of our devices?
I mean, I'm not really sure if there are any tools or anything. So you're saying if there's kind of like an automation tool which can run through the configuration and see if you are compliant or not.
Yeah.
Right. Yeah.
And
I mean, I'm not aware of any such tools, to be honest.
Okay. So it has to be us who needs to go through these regulations and make sure we design the correct way.
Right.
Okay. But anyway, there will be some standards for each and every organization, right? So those standards.
So most of the, so if you are, if you don't fall in any of these categories, right? Typically, you would want to look into MITRE-ATT&CK, right? Or ISO 27001. Okay. And
so those would be anything applied to any organization or any field.
Right. And mainly if you're in the United States, you will be looking at NIST, or even if you're anywhere else, you can probably combine what both ISO says and NIST says, right? And develop a cybersecurity framework for your own organization, and maybe add some things from the MITRE-ATT&CK framework as well. Okay, so it does not mean that you have to pick only one. You can pick a combination of these, right? But if you are an organization that handles credit card data, if you handle patient records, if you are European Union, then you have to make sure that you comply with these three, respectively.
Got it.
Okay.
Thank you.
Any other question?
No, I'm good.
Okay. Okay, moving on. We'll quickly talk about what do assets, threats, and vulnerabilities mean, right? So I've already told you what assets are, right? So an asset is anything, right? It can be a person, it can be a property, or it can be information, right? People can include your employees and customers along with any other people that come into your organizations, maybe contractors, temporary employees, or guests, right? Property assets can be both tangible and intangible items, right? Computers, hard drives, servers, etc. Okay. Anything that can be assigned a value, right? It basically is an asset. When you're trying to develop these solutions, when you're trying to design a security solution, when you're trying to implement cybersecurity, what you're trying to protect is you're trying to protect an asset. Okay. It can be a person, it can be property, or it can be information. Okay. Depending upon what sort of an asset it is, that is how you design your network and you design and pick up security solutions. Okay. Threat. A threat is something that can exploit a vulnerability. Okay. Now it can be intentionally or accidental, right? So a threat can work to obtain, damage, or destroy an asset. Okay. So when you are trying to protect an asset, what you're trying to protect it against, you're trying to protect it against a threat. Okay. Last is a vulnerability. Vulnerability is basically a weakness, right? It can be a weakness in an asset. Okay. Or it can be a weakness or gap in a security program, right? So let's suppose when I say property, maybe I have an application, right? That application was not securely developed. So it has some weaknesses or gaps. When it has a weakness or gaps, my application asset, it basically has a vulnerability, right? A hacker becomes a threat and he can exploit that vulnerability and can damage the application or the asset, or maybe steal the data or the information or the asset as well. Okay. Now, if I have an asset, but it has no vulnerability, right? Then there is nothing for me to worry about, right? Because if there is no vulnerability, then there is no threat. Remember, right? That's why when you work or when you do the cybersecurity frameworks, when you develop applications, when you design security solutions, always put security as the first thing, right? Because the only way to mitigate threat is by not having any weakness or gaps. This is again not possible 100% of the times, right? There is no way you can have 100% vulnerability free organization or program or application or device, right? If the device has a software running, it will have some sort of a weakness or a gap, right? And that's why you design security programs in such a way that you either can mitigate these weaknesses or minimize these weaknesses or gaps so that the threat cannot exploit your asset and damage or extract the information. Okay. And this is where we have risk coming into picture. Countermeasure, again, this is basically what we're trying to do, right? We are trying to eliminate or reduce the vulnerability. Okay, so a countermeasure is basically our safeguard, right? This is basically your cybersecurity frameworks, right? Your devices, your firewalls, IPS IDS, malware protection, email protection, cloud security. storage security, right? How do you design all of these and implement? They are defined by your cybersecurity frameworks. Okay, so that's basically what your countermeasure is. It's basically your safeguard, right, which can help to eliminate or reduce a vulnerability. Now, from that, talking about risk, what is risk? It's basically how vulnerable or what is the potential that my asset can be damaged. Okay, when a threat exploits a vulnerability, that is my risk. Okay, so what is my risk? That I'm going to drive a two-wheeler vehicle on the road and I might meet with an accident, right? So that's basically my risk. So usually this is kind of like a formula that you kind of use when you're performing a risk assessment, right? So how do you calculate your risk? You basically add your assets, right? What are the vulnerabilities and what are the threats for those vulnerabilities or gaps? Okay, and so it's basically your asset, threat, and vulnerability, right? So you add these up and you come up with what the risk is. Okay, I mentioned this. Threats may exist, but if there are no vulnerability, then there is little or no risk. Right? So let's say, for example, I have a Windows 10 machine, right? And it's maybe vulnerable to some sort of an RC attack, right? Microsoft released a patch for it, and my organization patched this machine, right? So now when I patched it, I am no longer vulnerable to this vulnerability, right? So my organization has no risk. But this threat is still present, right? It might be present for some other ABC organization who did not patch their computers, right? So if I have patched or if I have eliminated my vulnerability, then the threat can still be present. But if that vulnerability is not there, I have no risk, right? A similar situation here, you can have a vulnerability, but if you have no threat, then you have little to no risk, right? Again, I have a Windows 10 machine, right, in my organization, or I have Windows 10 in my organization. It has a vulnerability, but no one knows about it, right? It has not been discovered yet. Since this vulnerability has not been discovered yet, there are no threats. Since there are no threats, my organization does not have any risk, right? Because there has to be some sort of a threat which can exploit this vulnerability, right? Since no one knows about this vulnerability, no one has discovered this vulnerability, then there are no threats. If there are no threats, then there is no risk. Okay, so this kind of is twofold. I can have threats, but if I don't have vulnerabilities, then there is no risk. If I do have vulnerability, right, but there are no threats, then again, there is no risk. Okay.
But if there is a vulnerability, it can be exploited anytime, right?
It can be. So again, that's why it's mentioned that you have little to no risk. There is still a little bit risk that someone might figure it out, right? And then I am at risk. But then if I'm then at risk, then I can patch it when the vendor releases a patch, right? And when I patch this, again, there would be a threat, but then once I've patched it, right, again, I would fall into the category of no risk. So this is kind of like an ongoing process, right? That's why organizations, they need to be, and that's why when I was talking about cybersecurity best practices, one of the best practices I mentioned was to have a good patch management and software update regulation and rotation policy in place, so that you are regularly patching these vulnerabilities which the vendor may be discovering at their end as well. Okay, so if you keep up with most of those recommendations, then you would for the most part will always fall into the no risk or the little risk category. Right. And I mentioned the current log4j instance, right? So if an organization patches vulnerability for log4j on all the affected systems, the risk no longer exists, right? Because the vulnerability we have already eliminated because we have patched the systems. Okay. But the threat remains. Globally, the log4j threat will always remain now, right? But if an organization patches their own affected systems, that particular organization kind of becomes risk-free. Okay. So whatever we have talked about up until now, right? Identifying your risk, right? Doing vulnerability assessments properly so that you are proactively assessing threats, identifying vulnerabilities, right? Which are kind of critical for your assets. So all of these things, they kind of help an organization to minimize their risk and be as non-risk as possible. Okay, so I have put in this this little diagram here, which kind of shows the comparison between your risk likelihood and your risk impact, right? So likelihood basically is, you could say this as a chance or probability. It's a chance or probability that a specific threat will exploit a specific vulnerability. Okay. Impact is basically your damage. Right. So if a vulnerability has a high likelihood, right, or if a threat has a high likelihood to exploit, but the impact is low, I am at medium risk. But if the likelihood is high and the damage to my asset is going to be high as well, I'm at the highest risk. Okay. Similarly, if the likelihood is low, right, for a vulnerability to exploit or for a threat to exploit a vulnerability, and the damage is going to be low as well, I'm at the lowest risk. Okay, but in the same scenario, if the damage increases for my risk, damage increases for my asset, then my risk also increases from lowest to medium. Okay, so it kind of always goes hand in hand, the likelihood and impact. Okay, so depending upon how complex a vulnerability is, it might not be very easy for a threat to exploit that vulnerability, right? So that's why the likelihood sometimes can be low, even if a vulnerability is maybe very critical, right? But it might be very difficult for it to be exploited, or there might be specific conditions. For example, let me just give you an example for this. There is a vulnerability that requires physical access only, right? That vulnerability cannot be exploited remotely, right? So if I have a good biometric in position, right, I only allow certain people to go into the server room, the likelihood of that vulnerability to be exploited is very low because physical access is required to the machine. Not everyone is allowed into the server room or the IT rooms, right? And if that damage from that vulnerability would be low as well, then I'll be at lowest risk. But if the damage, if someone is maybe able to still exploit it, the damage is high, I still do not fall into the highest risk category. I still fall into just a medium risk category, right? Because the likelihood is low. Okay. Any questions on this?
Yes, I do have one question.
Mhm.
So in production also, we have to, if we want to remove this type of attacks, so we have to upgrade the patches, or we have to upgrade the iOS version.
It really depends. So usually, if there are vulnerabilities that have been discovered, there are patches or hot patches that are released. Okay.
Mhm. No, but what
Or
is the
in some
proof?
cases, yeah, sorry.
I mean, what is the proof? Suppose in my organization, they did BATP, vulnerability assessment test procedure, and they run some software like Nmap and Metasploit, and
Right.
then they said these are vulnerabilities. So what we did, we did upgrade the iOS version, and then we directly, we upgraded, so this vulnerability has been removed.
Right.
But we don't have any proof. We just search on internet and then we gave to the customer.
Okay, so you mean you need to have a proof. So usually what you do is your proofs are your vulnerability assessments. Okay, vulnerability assessments are usually your proofs. You usually do those through things like Nessus. Okay, Nessus is basically a vulnerability scanner. Okay, so you can have it running continuously and trying to figure out vulnerabilities on your devices, and you can then pull out reports from this to see what all vulnerabilities have been reported and what is the criticality, right? So usually if a CVSS score is of 10, it is critical. CVSS from 7 to 9 is basically high, and so on and so forth, right? You then have medium and low. So usually for organizations, this is the first priority, to remove these CVSs and then move to highs. And then some InfoSec policies mention that they don't really need to care about mediums and lows. Okay. So when you discover these through these vulnerability scanners, you can then do some research and see if your particular product is really affected or not, right? Cisco has their security advisories that they push out, or you can also look at CVE website and NVD website. Okay, and I'll cover this in another slide. I have another slide where I show both of these websites. So you can go to these websites, and whatever you get the vulnerability in these reports, you can check for more details in these CVDs.
Yeah, got the point. Thank you.
Right. So at any point of time, being in cybersecurity and being in security, you have to do some research, right? So a lot of things are automated and can be automated, but you would still need to be on top of doing your own research and being kind of current with whatever the current threat landscape is. Okay, risk management. So like I've already mentioned, we have covered CIA. So basically risk is a loss to CIA of assets, right? And there will always be some sort of a risk. Okay, there is no way to have a risk-free environment or system. Okay, your organization will always have users, will always have employees, right? They will always connect to the internet. They will always be liable to click some link or maybe put in some USB that they bought from maybe some shady market or something, right? Since you would be using your own softwares or maybe using vendor-based software, there'll always be some vulnerabilities in those softwares, which will have some vulnerabilities, which will have some sort of a threat against them. So there is no way to have a risk-free environment. The main purpose of us, or our main goal, is to have as lowest of a risk as possible for an organization. Okay. and following all the best practices and making sure that you know what your assets are, which are your priority assets, putting in sufficient security controls, following some sort of a framework to have kind of like a designated plan. Okay, firewalls need to be here, right? They need to do this. Endpoint protection needs to be here, needs to do this. Having data backups, having some sort of redundancy, and all these things, they kind of work simultaneously and comprehensively to give you a low risk environment. Okay, so you can never have a risk-free environment. Okay, so if an organization says that they are risk-free, then they probably are kind of joking. Okay. Now, again, risk management, it's basically nothing but risk assessments. Okay. So managing risk, it basically allows the process, or it's basically the process for you to identify and assess and reduce the risk to an acceptable level. Okay. Again, I've not mentioned to remove the risk, because again, there is no way to remove a risk or have 100% risk-free environment. Okay, so there are two types of risk assessments. One is a quantitative and another one is a qualitative risk assessment. Okay, quantitative risk assessment basically means that you are putting some value against each specific risk. Okay, so when I talk about quantitative, you put some value against it, right? So maybe you have a server which deals with credit card data, right? Or maybe you are in the European Union and you deal with customer data, and there are some servers which only handle that data. If that server that compromises, right, you would need to pay some sort of penalty, right? So you are basically trying to map a value. Okay. Qualitative is basically just putting, what should I say? Just assigning a risk level, right? Whether my risk is low, it's high, it's medium. So these are the two types of risk assessments that do. One is quantitative, which kind of puts a value on the risk. And then depending upon that, you also do a qualitative through which you can put a risk level against that risk. The same thing that I showed you on the table on the last slide. So it's kind of doing that. Okay, so these are the two types of risk assessments. Now, again, there are lots of different risks, right? You have a business risk, right? If you are doing business or your organization is doing business, you're already at risk. Right? So it can be anything. It can be economic, it can be inflation, right? It can be someone trying to hack into your networks. It might be your own internal employees that you have hired, etc., etc., right? So if you are doing business, you're already at risk. Okay, so one is your business risk, then is your data risk, right? Whatever we have talked about, data leakage, maybe data corruption, right? All of these, they fall under the data risk category, right? Along with data risk, there is also things like your data loss, right? So you can use both of these interchangeably. Okay, then you have your systems risk, right? Your organization is using devices, is using computers, iPads, etc., servers, right? They all are at risk of failure, right? Your hard drive can fail, your servers can go down, right? Maybe software crashes, different types of issues. Those fall under the systems risk category. Insider threat. We already talked about the insider threat, right? Your own employees, right? Maybe you did not give them a good raise, right? You did not promote them. You fired them for whatever XYZ reason, right? So they all can become a risk as well, right? Then you have an application risk. Okay, what if your application fails, right? You could have financial damage, right? If your application does not do input validation or has not been securely coded, then it can lead to further issues, right? So if you're using some sort of an application, again, you are at risk. Third-party vendor risk, okay? If you are outsourcing your work to a third-party vendor, or maybe you are getting some contractors or temporary employees on contractual basis coming into your organization and working, that is a third-party vendor risks, right? You never know who might do something bad with the data, steal the data, or do some sort of a data breach, right? And then the last is lacking any compliance measures, right? Things like your PCI, your HIPAA, your GDPR, right? So if you are working, or if you are in any of these industries which deal with these three compliances, if you are not compliant with these compliance frameworks, then you are at risk, because if you don't handle the data properly, and if you lose that data, you can be penalized, or you can even or you might even have to serve jail time. Okay, so these are some of the risks that an organization basically has to deal with, or can deal with. Okay, so I've talked about all of this already. Right, now some options to managing risk. First is a risk acceptance, right? So there has to be a point where you have done everything, right? You have the latest and the greatest devices, you have the latest and the greatest technology to actually mitigate. You do vulnerability assessments, you do compliance, everything, but there is still always going to be some sort of risk. Okay, so you need to accept some risk, okay, depending upon what the current level of risk is, which is basically through your qualitative assessment, and then the cost, basically quantitative assessment. Okay, so that basically falls under the risk acceptance category. Risk avoidance, again, doing all the things to stop the activity that has risk, or choosing a less risky alternative. Okay, so maybe you fear that if you hire temporary employees, or you do third-party vendors, then you might be at risk for data breaches or some other things, right? So you can avoid that risk by not going that route, or not by hiring any contractual employees, or relying on third-party vendors. Okay, so that is risk avoidance. Risk mitigation, again, minimize the risk to an acceptable level, right? Do everything that you can to mitigate the risk as much as possible. Risk transfer, you have insurances, you have life insurance, health insurance, all those things. Organizations have their own insurance. So if there is a risk, and if something happens, then I can transfer that risk to a third party, something like an insurance company, right? So that's another way to manage risk. Right? If my data gets stolen, not really data, if my servers get stolen, or any physical asset gets stolen, maybe my laptops get stolen, right? So if I have an insurance on those, I can claim that money back, and I can minimize the risk. So that's basically risk transfer. And residual risk, after doing everything possible and all of this, there is still some risk which will fall under the residual risk category. Okay, so residual risk is the risk remaining after trying to avoid, transfer, or mitigate the risk. Okay, so that will fall under the residual risk category. This will always be there, right? Because there is no 100% risk-free environment. Okay, so we'll see next CVSS, or the Common Vulnerability Scoring System. Right, we'll go over this quickly. Right, so the Common Vulnerability Scoring System, it's basically open and free, right, to industries for evaluating the seriousness of the vulnerabilities, right? Seriousness or severity. So it's basically used in a lot of vulnerability management software. So if you're using something like maybe Nessus or Necto, and if they find out a vulnerability, they basically assign a vulnerability score, or a CVSS score, to that vulnerability, right? Which is based upon a lot of different metrics, and I have a slide for that. And they are given a score between 0 to 10. So like I've already mentioned, 10 is the most severe score. It's also, so if a vulnerability gets a CVSS score of 10, then that is basically considered a critical vulnerability. Okay, that's the highest severe vulnerability. If you have critical vulnerabilities in your environment, in your network, those are the first ones that you should work to mitigate. Okay. This is the non-profit organization, which is based in the US, that basically owns and manages CVSS, first.org. So you basically don't need to be a member or basically so you basically don't need to be a member of this organization to basically implement CVSS in your software or in your environment, right? But it kind of does require any individual or organization to give appropriate attribution, okay? So there are basically 3 different metric groups within CVSS. You have base, temporal, and environmental, okay? The base metrics are the ones that actually produce the score, okay? And this base score, this basically can be modified or is manipulated by the temporal and the environmental matrix. Okay. Previously, there used to be a CVSS score of, a CVSS version 2. Okay. Nowadays we have version 3. So they have made some changes in the way the 2 was, and now basically they are using 3. So we are currently on 3rd major version, which is version 3.1. Okay. It was designed to address some of the shortcomings in its predecessor, which was the version 2. Okay. So there were several changes made in the base group. Okay. So again, you are going to see a lot of the CIA throughout your studies and throughout your career within the within cybersecurity. So make sure you properly understand the CIA triad. Okay, so I've highlighted some of the changes that were made from version 2 to 3. Okay, and we will go over these when I'll show you the matrix. Okay. So confidentiality, integrity, and availability matrix, they actually were changed, and now they have a scoring parameters of none, low, or high. Okay, so that's how we are going to, when we'll see a vulnerability and a CVSS score against a vulnerability, for things like confidentiality, integrity, and availability matrix, we are going to see that they are assigned a score of either none, low, or high. Okay, and when I say none, low, or high, so basically what this means is, so let's say a vulnerability has confidentiality that has been marked as low. So it basically means that if that vulnerability is exploited, right, how much confidentiality of the data will be exploited, right? So if it's low, then means that the confidentiality breach would be low. Okay, there can be some vulnerabilities in which the confidentiality breach would be none. Okay, so no data can be seen, no private data or no secret data can be seen or extracted. Okay, and if it's high, that means that the complete confidentiality of the data will be breached. Okay, same thing with integrity, same thing with availability. Okay, so that's what the none, low, and high means. There's an attack metric. So within version 3, they added a physical value to it, right, which indicates a vulnerability where the adversary, by adversary, you can think of it as the actual hacker or the attacker, must have physical access to a system, right? This was an example that I already covered previously, that there might be some vulnerabilities where the hacker needs to have physical access to the system in order to exploit the vulnerability. So CVSS version 2 did not have the physical value parameter. With version 3, they added that within the attack vector. They also added a new user interaction, right? Now, there are some vulnerabilities which are termed as zero touch. Okay, that means that a user does not need to do anything and the vulnerability will still be exploited. Okay, and then there are some vulnerabilities which actually require some sort of a user interaction, maybe clicking a link, right? Maybe there's an exe file, malicious exe file, maybe there's a malicious image file, right? Can be a CSV document, right? So opening up those. So all of these, they fall under the user interaction category. Okay. So there are some vulnerabilities which are zero touch, we don't need any user interaction. So these are obviously, as you might think, these are more dangerous, right? Versus vulnerabilities that need some sort of a user interaction. So CVSS version 3 added this within the metric as well. Another new metric that was added was privileges required, right? This basically added to indicate that administrative or other escalated privilege in target system must be achieved, right? What do you mean by that is, so whenever someone tries to exploit a system or a server, what they're trying to gain is they're trying to gain admin level privilege, obviously, right? When you get an admin level privilege, you can do anything, right? So that's the end goal for any hacker, right? They can manipulate databases, they can make configuration changes, they can read config files, they can download copies of configuration, they can download database, etc., etc. They can delete, reboot systems, crash systems, etc. So the main goal or the end goal for any hacker is to gain admin level privilege on a system. Okay, so usually if a vulnerability gives them access, they can get a low user level access. What they try to do is they try to escalate privileges to admin, right? Obviously, since this is the end goal. So CVSS version 3 has added this privileges required matrix. So what now a vulnerability can mention is that in order to exploit a particular vulnerability, admin privileges are required, right? Obviously, which makes the vulnerability much more difficult to exploit, because it might not be always easy to escalate these privileges from a low level to a higher level user, right? If a vulnerability says that a user level access is sufficient for a vulnerability to be accessed, then this would be a much more critical or a much more dangerous vulnerability. Okay. Now, there have been some environmental group changes. Okay. So within the version 2, so they have completely replaced what was there in version 2. Okay. And the base matrix have now been modified so that the organization can reflect the differences. So what do I mean by this is, let's say there's a vulnerability, right? It has some of these parameters, right, which basically gives it a CVSS score. Let's say it has a CVSS score of 9.0. So this is the base score. Okay. There are two organizations. There's an ABC organization and then there is an XYZ organization, right? So ABC organization has some of these, some of the security controls in place, which kind of makes it difficult for this vulnerability to be exploited, depending upon how their environment is, right? XYZ does not have such sufficient technical control. So it's easy in the XYZ organization to exploit this vulnerability. So what the organization, this ABC organization can do is they can basically, for their own environment, because some of they have better security controls, they can manipulate this base score. So that's why CVSS, that's what CVSS version 3 gives the ability to do, right? So this is what the global databases say. ABC says that, hey, my organization has better security controls. And for my organization, this CVSS score needs to be 6.0. Only for my organization, for this particular vulnerability. XYZ does not have sufficient, so it might say, hey, for me, this needs to be a 9.0, right? Because I don't meet or I don't have sufficient security controls to mitigate these metrics. Okay, so this is the biggest change that came in with CVSS version 3. Okay, so the base matrix, they can be modified by an organization to reflect the differences, okay, between their situation and environment versus others. So ABC organization situation and environment is much different from what XYZ has. So that's why ABC can say that, hey, you say that it's 9.0, but I have these security controls in place to avoid this threat or to mitigate this vulnerability. So I would say for my organization, this is not going to be a high vulnerability, right? This is going to be a medium vulnerability for me, right? XYZ says, hey, for me, this is going to still be a high vulnerability. Okay, makes sense?
Yes.
Yes. But where
Okay.
would they make these changes? Like once the CVSS score is provided for a vulnerability, so how do you change it for a particular organization?
Yeah, so you can do it within maybe the vulnerability assessments when they are done, right? You could make the change. So that's basically for your own organization. Okay, when you're saying XYZ, that would be for your own self. Okay, for your own documentations, for your own InfoSec policies.
So once we get the report from whatever the vendor, so that means depending upon our security posture, we can change those.
Right.
All right. And is there a specific formulas like if it needs, if any vulnerability requires user interaction, so I can baseline my CVSS score for my organization. So
correct.
Is there a specific formula for it? Like
sorry, didn't get the last part.
Can we specify a formula kind of thing to just for our report, depending upon the vulnerability?
There's no real formula. So I think first.org has a tool on their website. So you can go in there and then you can make the changes to the matrix, right? So for example, if you have the user interaction, so when you put all those information, it's going to give you a revised matrix or a revised score. Right, which will be only for your organization.
Yeah. Is it first.org?
Yeah, first.org.
All right. All right. Yeah, thank you.
So CVSS version 2, qualitative scoring mapped to one of the three severities. It used to be low, medium, and high. Okay, so this is how CVSS 2 used to do qualitative risk assessment or risk levels. It used to assign this way. Now with CVSS version 3, the scoring range remains the same. It's still from 0 to 10, but is now mapped to 5 different qualitative severity ratings, right? So for 0, it's none. Then you have low, you have medium, you have high, and then you have 9 and 10 be critical, right? So one issue, okay, I'll talk about that later. Okay, so this is kind of like the change in the mappings from CVSS version 2 to 3. So I've put in this this small study here, which Cisco did. Okay, so what basically it did was for a lot of organizations was, let's see. Yeah, so previously, if the organizations were following CVSS version 2, if you're going to look here, 7 to 10 used to fall in high category. right? Now 9 to 10 falls under critical, or high only has 7 to 8.9, right? So when we moved from CVSS version 2 to version 3, and a lot of different metrics were basically introduced, right? Which kind of increased, on an average, the base score of the vulnerabilities were increased from 6.5 to 7.4. This is an average. Okay. So for all the vulnerabilities that are out there, the base score, because of the new matrix that we discussed that were added and the way that the changes were made, the base score was increased from 6.5 in CVSS version 2 to 7.4 in CVSS version 3. Okay. Which means that the average vulnerability increased from medium to high. Now, what this did for the organizations was, let's suppose, so most of the organizations, usually they don't really care about low and mediums, right? They only care about highs and criticals, right? In my opinion, they should also care about medium. Lows are something that you can probably ignore, okay? But there are some organizations who want to have a vulnerability-free environment where they also don't want to see any low vulnerabilities in the vulnerability assessments, okay? So previously, these organizations who only catered to highs and criticals, so let's say an organization ABC had maybe 100 mediums, which they really don't care about. When we change to CVSS 3, these hundreds, they now fall under the high category. So now instantly, when now the vulnerability scans are happening, these organizations, they are getting 100 plus high vulnerabilities that need to be taken care of, just because of this base score that was increased due to a change in the way that the matrix happened. Okay, so not really a problem, right? But the thing that the study, which was done by Cisco, it concluded that far more vulnerabilities increased in severity, obviously, right? A lot of the ones that fell into medium, they went into high, and similarly, a lot of the lows would have gone into mediums, right? So it kind of would have put on more load on the people who are doing vulnerability assessments, who are trying to fix these vulnerabilities. So when you start getting these high number of vulnerabilities, you know, that kind of was the study that was concluded. So I have this linked. When I'll share this PPT, you can probably view that study. It was, okay, wait a second, what happened? Yeah, we are here, right? So it was done by their principal engineer. If you have heard about him, Omar Santos. He's the principal engineer, or he's the principal cybersecurity engineer and architect within Cisco's PCERT and CCERT team, right? They are their incident response teams. So he's the principal engineer, the primary architect within that. So he did that study. So he has nice graphs and charts. So you can probably view them, go over it once and see how many vulnerabilities increased and what was the real impact for those. Okay. So SCOR matrix. So this is what the actual matrix looks like. And I'm talking about the values, okay? So within a CVSS marks, or when you see a vulnerability, you get a CVSS and you get something like A, and it has a value. You have, sorry, this would be, let's say AV, you get a value. You get AC, you get a value. You get a PR, you get a value. Right? You have UI, you get a value. Right? Scope, you get a value. So this is how a CVSS is written. Okay. So all of these metrics are mentioned within the CVSS in kind of like a shortened form, right? In an abbreviated form, right? And then they all have some value which kind of, is given. So this is the exploitability matrix. These, right? So this is basically the vulnerability component, right? So let's see, when I say attack vector, right? It basically means, or this is basically based upon the level of access that is required to exploit a vulnerability, right? So for example, the score will be higher for exploits that can be remotely executed, right? So if the attack vector has remote, it will be a high value. If the attack vector is a physical access, it will be a low value. Okay, so every vulnerability gets a score for all of these metrics. And all of these metrics, and depending upon how severe or how high all of these vectors are, that basically makes up that CVSS base score that you see, which ranges from 0 to 10. So all of these factors, they come into picture. So for example, I talked about this attack vector. Next is the attack complexity, right? So what this basically means is, or this basically is based on the factors outside of the attacker's control, right? That are basically required to exploit the vulnerability. In case of attack complexity, the score will be higher for exploits that require additional work on the attacker's part. Okay. For example, for an MITM attack, right? If the attacker needs to do something to steal the secret key or the shared key, right? In case of encryption or VPN, right? So this value or this score will be higher because the complexity is more. Okay. There might be some attacks which require no additional work on part of the attacker, right? No crafting of packets, no writing any code or anything. That will have a low attack complexity. Okay, so if the complexity is high, the base score will be, so that is what is going to change, increase or decrease the base score. So every single component comes into picture. So privilege is required and user interaction has been added newly, right? So again, privilege is required. If a vulnerability requires admin privileges, like I've already talked about, it will have a higher score. If an exploit does require no authentication, right? So there are vulnerabilities which require no authentication. That means an attacker can just access the system without requiring it to supply any username and password, right? So those would be much more critical than vulnerabilities that need some sort of an access or authentication. For example, admin access, right? Because the attacker would need to spend more time and the complexity and the difficulty would increase. Okay, similarly with user interaction, right? So all of these, they kind of work simultaneously, or all of these, they kind of give this CVSS base score a value. For example, the impact. So what will be the impact of the vulnerability, right? Impact will be on the CIA triad. Will it impact, how will it impact the availability? How will it impact the integrity? How will it impact the compatibility or confidentiality, right? So if it will impact the confidentiality in a low manner, then obviously the CVSS score will be lower, right? If all these three are high, basically the availability will be affected, the integrity will be affected to the maximum severity, the confidentiality will be affected to the maximum severity, then yes, the CVSS base score will be higher. Okay, and then similarly, all of these things here. Any questions on this? So you can check out first.org. Right? To understand and to see things in more detail, right? To really look into a lot of the theoretical concepts, but at a very high level to understand what the CVSS is and how does the base score comprise. I think I've covered enough information for you to, maybe maybe if you do vulnerability assessments in your organizations, you can maybe pull up a report from last month, see which ones have a 9, right? And then see what all metrics are mentioned and what their values are. And then compare it with a vulnerability which has a CVSS score of 5 and see what all these metrics have got a score and compare the differences, right? So that's kind of like the best way to understand how these metrics, they basically affect the CVSS base score.
Yep. Yeah. In our organization, we do work with Cisco PSAT team, and we get a report quarterly on all the Cisco devices that we have. Yeah, and we mainly focus on high-end critical research only.
Okay.
Yeah, once we address those high-end critical, then we go to the medium ones.
Yeah, so that's usually the way InfoSec policies are. Obviously, you should always be looking at criticals and highs first, because if it's critical, it's going to fall in the CVSS 9 or 10 now with CVSS 3, right? So these are usually the ones which are always going to be the top priority. These ones are usually the ones which have things like your remote code executions, no authentication exploits, and all those things, right? And these are going to be much more critical. Okay, moving on to the next module. So we are going to look at some of the attack vectors really quickly. So we're going to see the difference between, so what basically attack vectors are, what is the difference between an attack surface and an attack vector. We're going to see some of the types of attack vectors. We'll look at some malwares and its types. I'm going to just give you a list of some of the TCP/IP attacks. I'm going to show you a little OWASP top 10. So this is basically for application security. Right? Again, this is an independent organization, OWASP, which comes up with top 10 vulnerabilities. I think it's every 4 years. Okay, so every 4 years, they do a top 10 list. They do a top 10 list of the most critical vulnerabilities. So if you are doing something like application security, you should reference this list to see what does OWASP's top 10 list for that particular 4-yearly time period is. So the last list came in 2017. Recent list came in 2021. Okay, so they kind of have things like your injection attacks, authentication, logging issues, all those things. Okay, so you can take this as a baseline when you're trying to develop applications, right? So it kind of gives you a holistic view of, okay, these are the top 10 vulnerabilities which nowadays are affecting security, application security. So you need to, or you can develop your applications based around those parameters, which can help mitigate these security vulnerabilities. Okay, and then we will finish this off with social engineering. So let's say if we let's see if we will be able to finish this today or not, or it will spill over into the next week. But I'll probably try and finish it as much as possible today. Attack vector, it's nothing but it's basically a method that is used by a hacker to basically gain access to a network or the application, right? So basically a method in which they can access or exploit vulnerabilities. Okay, so that's basically an attack vector. Okay, so a lot of these methods or a lot of attack vectors can be your email attachments, web links, pop-up windows, right? Instant messages, maybe things like on WhatsApp or something similar, right? They can be sent to employees or individual users. So those are the attack vectors. So anything that can help a hacker or a malicious actor to exploit a system or to gain access to a system, right? It basically can be categorized as an attack vector. It can be protocols, right? So a lot of security vectors, they are, like I said, it's financially motivated, right? Which means that if I steal your personal confidential information, I can sell it out to maybe your competitors, right? Or maybe I can put those listings up on the dark web and I can gain financial assistance, right? Or I can get some money out of it, okay? Or in case of ransomware, I can just upright demand for ransom. Okay, we have already talked about these, right? Former employees, these are your insider threats, right? Politically motivated groups, we already talked about professional hacking groups, state sponsored when we talked about APTs, right? Advanced persistence threat, okay, APTs. And then you have things like your hacktivists who are basically, I would say, politically driven, right? Let's say they're trying to run maybe a propaganda or something. They hack a government website and they put up a banner regarding any particular political issue or global issue or anything, right? So those guys, so these guys usually, they don't, they are not looking for any financial gain. They just want to push out the propaganda. Okay, so they won't do any damage, they won't steal anything, but they will just hack it and probably just put up a banner or maybe seize the service, maybe do a DOS attack if they're not happy with the government or anything, right? Or maybe any other organization for that matter, not just government. Okay. Now, like I've mentioned, cybersecurity attacks are done through an attack vector, right? Your emails, your messages, even phone calls, right? Someone can call you and maybe pretend to be from Microsoft support or from Airtel or maybe from Vodafone or maybe from Amazon and ask for a username and password, which basically is a form of social engineering attack, right? So all of these are attack vectors, okay, which is aiming to steal user credentials, user data, get unauthorized access to corporate data, right? An attack surface is basically the total area, right? It's basically a total area which an attacker can use to launch these vectors. Okay, so for example, devices, people, right? They are all part of an attack surface, right? Why? Because these people, they can have weak passwords, right? They can have unpatched software. So these things can be exploited by using a form of attack vector. Okay, so that's basically the main difference between an attack vector and attack surface. An attack vector is a method by which a hacker or an attacker can exploit an attack surface, which can be devices and people, right? Which in turn gives them access to weak passwords, which is again an attack surface, right? Or unpatched software, right? Or maybe if they are doing application, right? They are not doing input validation properly. Right? So all of those that they kind of can use an attack vector to exploit them. Now, there are different types of attack vectors, right? Primarily, there are two, right? One is an active and one is a passive, right? So a passive attack, it basically occurs when the attacker is basically monitoring a system, right? So this is basically just to gain information, right? An example could be an MITM attack, right? Where I can have my PC and I can run Wireshark, right? And I can listen for traffic going from A to B, right? So I am doing a passive attack here. Or you can also term this as reconnaissance, right? I'm doing a recon. I'm trying to gain information, right? I'm not trying to damage, right? I'm not trying to steal. I mean, I'm trying to steal, obviously, but I'm not trying to damage any system, right? So this is basically passive, okay? I am not directly interacting with the systems, okay? I am just sitting in the middle on my own PC. I have a Wireshark, or I can have any other sort of packet capture in place, and all I'm trying to is capture the data, right? Active packet session captures, right? This is passive reconnaissance. There can also be active reconnaissance, right? Where I can use port scanners, right? Things like Nmap, which is short for network mapper. Okay, so this is basically an application which you can run on Windows, or this comes pre-compiled on Kali Linux, right? So this basically can be used to get information about the ports that are open on a particular server or a particular machine, right? And then I can look for vulnerabilities that might be related to that particular application, right? So since when I'm doing Nmap, I'm directly interacting with some sort of a PC or a server, that's why it's called as active. Okay, so active is when I'm directly interfacing or when I'm directly interacting with a server or a machine. Passive means when I'm not directly interacting with a machine, I'm just sitting there and trying to run a capture and trying to just gather information. Okay, another example could be phone tapping. Right? I'm not interacting directly with anyone. I'm just sitting there, connected my phone on a line, and then I'm trying to get information or listen or eavesdrop whatever is the interaction between A and B. Active attack, right? They are basically attacks that you're actually performing, right? Things like DOS attacks, okay? Things like you're trying to do brute force attacks, right? These are basically password attacks. So you are continuously trying to send username and password combinations to a server, right? So you have an application that is basically running, which is kind of sending passwords every single second, trying to brute force your way through the server, right? So all of these, since they are directly interfacing with the server, and DOS attacks, which are meant to disrupt service, or obviously it can damage, crash servers or asset, right? So all of these, they are considered to be an active attack. Okay, this is an example that I already told you. An intruder, it pretends to be a trusted user, right? It can, so someone can pretend to call from maybe Amazon support, right? And they can ask for your credentials, right? So that's basically stealing credentials. And this intruder, he's directly interacting with the user, right? So that's why it's an active attack. Okay, moving on to malware and types. So like I mentioned previously, malware is nothing but this is short for malicious software. right? So you took the mal from the malicious and where from the software. So that's what makes it malware. Okay, so it's a malicious software. It's basically malicious. And what is software? It's nothing but it's a piece of code, right? So depending upon how that piece of code has been written, it can either do good, right? Or it can do bad, right? So when it does bad, it's basically considered malware. So there are different types of malwares that you would probably see, listen, or hear, okay? You have viruses. We already know what viruses are. You have worms, right? So the difference between virus and worm is that unlike a virus, a worm is able to replicate itself without user interaction. Okay? So that's the main difference. It is self-replicating. So the code has been written in such a way that it can self-replicate and spread, right? And it does not require user interaction, no user interaction. Okay, so if you want to read about a malware, there was a malware in 2000. Sorry, there was a, why does it keep changing? So there was a worm that spread in 2009. And it affected, I believe, somewhere around 15 million computers worldwide, right? So it spread to so many computers, right? It was known as configure. Okay, so if you want to, you can read over it, and I'll talk about, and I'll go over when I'm talking about these, I'll give you some examples so that you can go back and read some of this information and get more insight into what are all of these and some examples of them. You then have Trojans. Okay, Trojans are basically disguised software. When I say disguised software, I can have an exe executable look like a PNG file. Okay, so when a user, obviously it requires user interaction, when a user double clicks the PNG file thinking that it's an image, he basically executes the executable file. Okay, so that's basically a Trojan or a Trojan horse. So if you look at antiviruses, a lot of times you see Trojan horse detected, right? So those are Trojans. So they are disguised malicious software or files, right? Which hide their identity, physical identity, right? A type of Trojan is a RAT, remote access Trojan. Right? So take this example. So the user thinking that it's an image file, he executed .exe. What this exe does is it installed a backdoor on the PC. Right? So what it did was it kind of opened up a random port and it's listening on that random port. And the user is not aware about it. So what now can be done is the attacker can connect to this random port, right? And gain access to the PC. Okay, so that's basically Trojan. And then when it kind of aims to gain an access, or the attacker tries to gain an access through a backdoor, it's basically known as a RAT, or a remote access Trojan. Next on the list is ransomware. We are all aware about ransomwares. Ransomwares have been creating a lot of issues, a lot of problems now as well, especially once we have been in pandemic and have been working from home. So ransomware, again, it basically is a type of malware, right? It basically is meant to restrict access to a computer system until a ransom is received or a ransom is given, right? I'll give you an example of it. Recently, I think there was, I don't remember the country, there was a radio house that was somewhere in Europe. They went into an attack for ransomware. It was a very big attack. There was another that was named as SamSam, right? This affected city of Atlanta. Okay, it was a ransomware attack, and it cost $17 million in damages. Okay, so if you want, you can read about SamSam. Next are your spywares. So there are basically three categories within these kind of, I would say they are non-malicious, but they are still malwares. Why they are non-malicious? Because they are not trying to damage, they're not trying to get or give anyone access or anything, right? So there are two categories. You have spywares, you have something that is called as an adware, and then you have something that is called as a grayware. Okay, so spyware, as the name suggests, it's trying to spy on you, right? It's trying to gather information about the user without their consent. This can be things like, so if there's a spyware that is connected, right, or that's installed, maybe it is programmed to whatever you type on your keyboard, it can save that in a text file and send it to the attacker. Okay, so spywares are usually meant to do that, or take screenshots, save them, and send those to the attacker. And this is all without the user's knowledge, not interaction, without the user's knowledge, right? So the user is not aware that something like this is happening at the back end, right? So you might be visiting your bank website, social media accounts, anything that you type on the keyboard, it basically gets saved. So that is another reason in a lot of places they restrict the usage of a physical keyboard and only use virtual keyboards, right? If it's a virtual keyboard, there is no keystroke, no physical keystrokes, right? So in that case, they're trying to circumvent any spywares that might be installed. Okay. You then have adwares. You would have come across these sometime or the other, right? You must have seen, I mean, in earlier days when we were on Windows XP or maybe Windows 2000, etc., we used to get a lot of pop-up windows, right, with various advertisements or anything, right? So that's done by adwares. Okay, so what the adware is doing is it's spying on you and trying to see what you're trying to look for. Maybe you're trying to search for a toy or something, right? And it will then start giving you pop-ups or advertisements for that adware. Okay. The next category, grayware. So this is basically just a software which I would say is neither malicious It's nor benign, right? It is just meant to make your system behave improperly. Okay, and I don't have example for the software. So there is a software which I can install on your system, and I can remotely get access to it, and I can do a lot of different things, right? I can flip your screen remotely. I can have your mouse, spin the cursor. I can have your cursor go in the opposite direction, right? So kind of like a prank based thing. It's just meant to make your system behave improperly. So that's why I was saying it is not malicious, not benign. So it is not trying to do anything bad. It's kind of like just a fun or a prank. I mean, not that you should do that. And I'm not advocating to the use of grayware, but it's just that, nothing else. Okay, so that's basically a grayware. Next are your rootkits. Okay, so these are basically designed to gain admin access over a system without detection. Okay, so a lot of rootkits, and for the most part, rootkits are kind of invisible to antiviruses, right? Because they kind of are present in, or the rootkit basically get activated even before the operating system is booted. Okay, and that's why they're very difficult to detect. Okay, an example of a rootkit could be DLL injection. So a lot of times, if you run antivirus software or scans, you're going to see a lot of DLLs being flagged as being malicious, right? So they could indicate that a rootkit is using these DLLs to hide its presence. Okay, there is also something that is known as driver manipulation, right? In some cases, it is also known as a shim or shimming. Okay, so what this is, it's basically an attack that basically relies on compromising any kernel-based or kernel mode drivers, device drivers, right? So maybe you're using some sort of a USB device, right? Maybe a mouse or a keyboard, etc., right? So anything that's connected to your computer, be it your hard drive, be it a monitor, etc., they all need drivers. Okay, so basically, a shim is something that is placed between two components to intercept the calls. And I'm talking about this from a kernel or an assembly language perspective, right? So if someone is trying to type something on the keyboard, right, it's going to make a call through the driver, and it's meant to make a call to whatever device it's trying to reach out to or input out to, right? Maybe monitor or something, right? So a shim is placed in between here, right, on the driver, so that these calls, the keyboard making the call to the driver, and then the driver making the call to either the input or probably the output device, right? So this information can be intercepted. And all of this is happening at the kernel level, right? Where we have our assembly language. So these are some of the most sophisticated malwares out there, rootkits, okay? They are very difficult to remove. They're very difficult to detect, okay? So usually, for the most part, the only way to remove them is by doing a fresh install of the operating system. You then have something that's called a spam, okay? Spam is basically, spam can be any activity, right? That basically abuses any messaging systems. Okay. If you're going to check your Gmail or any other email, even your corporate email, you're going to see a lot of spams, right? So what these are is maybe the ad companies or maybe a lot of product-based companies. What they're trying to do is they're trying to use companies' open mail relays, right? Open mail relays to send these messages, right? In the US, I believe it's in the US, they have an act specifically to cater to spams. It's called as CAN-SPAM, Act of 2003. Okay, it's specifically meant to cater to these spam type emails, right? So you can probably go ahead and read about that. Next, we have things like botnets and zombies. And I talked about botnets and zombies when we talked about the CIA triad, and I talked about the denial of service and distributed denial of service attacks, right? So again, botnets are these, they are basically a collection of compromised devices. Okay. Now, these devices can be anything. So usually attackers attack IoT devices because they are brainless devices, for the most part, right? They are not usually updated. They are not usually patched, right? Things like your cameras, right? Things like maybe the bulbs, right? Which connect to the internet. So all of these things that they don't have updated software systems, so they're mostly vulnerable. So what the attacker does is it installs a piece of malicious software on, let's say, these cameras, right? What it then does, these cameras, they then go under the control, or they talk to what is called as a CNC server, a command and control. Whatever instruction the attacker sends through this command and control server to these cameras, they do that. Okay. So individually, this hacked camera will be known as a bot. And if I'm using maybe 1,000, or I have 1,000 of these in my control, then I would call these as botnets or zombies. And these are used in DDoS attacks, right? So let's say I have all over the world, I was able to compromise 1 million IoT cameras. And they are spread throughout the world, which means all of them have a different source IP address. Me being an attacker, I can send an instruction through the CNC server and tell them to attack any XYZ organization. So this organization is going to see traffic coming in from all 1 million of these cameras. So that's how usually denial of service or distributed denial of service attacks are carried out, right? Since these are very easy to hack, to compromise, so people usually use a website known as Shodan. Shodan basically shows, it's basically a recon website. It's available publicly, so anyone can access it. It's also part of OSINT, or open source intelligence, right? So if you go on to Shodan and if you check any categories or anything, it will actually give you a list of devices throughout the world that are online and connected to the internet, along with the IP address and everything, right? So a lot of attackers, what they do is they keep reviewing this website to get a list of some of these devices. So let's say I see a lot of HP printers online. What I can do is, as an attacker, I can do some research on any latest vulnerabilities that these HP printers might have. And since they are connected to the internet and I can see it, they're online, then over the internet, I can try and hack them. If I am successful, I can install my piece of code and I can do this across various different machines, right? And then once I have them under my control, I can carry out a distributed denial of service attack on any organization. Okay, so that's how usually a distributed denial of service attack happens, which is distributed since it's coming from a lot of different source IP addresses. So it's super difficult to mitigate, right? Backdoors and logic bombs. So this is probably the last category. I have already talked about backdoors, which become as part of your rats, right? Logic bombs are another interesting thing. So I was talking about insider threats. I'll tell you a little, I mean, I don't remember who or what the person's name is or what organization were they working for, but there was a person who was an admin for this big organization. And he knew that in the next quarter, he is going to be fired, right? Obviously, when you're working in an organization, you kind of are aware what is going to really happen in the next quarter or maybe during the next appraisal cycle or whatever. What this admin did was he installed a malicious code on the main server, on main servers, right? It was a logic bomb. What it meant to do was, at a specific date, midnight, it changed the admin password across the whole organization. So when this guy was fired a couple of days before, or maybe a week before, so he did that because, I mean, obviously insider threat, right? So he actually did that so that no one will be suspicious about him, obviously, because this is happening 1 week after he left. Okay, so these are called as logic bombs, right? They are inserted in a program or maybe on a server, and they will execute only when certain conditions are met. So in this case, the condition was a specific date and time. Okay, so now that organization was left with their servers, which no one could access because the password was changed to some random numbers, right? And you could do a lot of different things with this, right? You can maybe delete configuration files, right? On the server, maybe restore to factory default. Okay. Any questions on these?
No. And Arun?
Yes.
How long do we have this session?
I'm going to finish this now. I think it's 9:30.
Yeah.
So yeah, we'll call it a day for today.
Okay. And in general, what are the timings for these classes?
So usually it is going to be starting at 7, and then we are going to be going up until 9:30 or even 10, depending upon if everyone is comfortable with going up till 10. Then we can do like 3-hour sessions, which will be better, and we'll be able to cover a lot of material as well.
All right.
So today,
Yeah.
so today I'm finishing at 9:30, and then when we'll meet next weekend, we'll probably see if we can go up until 10 and get some more content covered.
All right.
Okay. Yeah. So this would be it for today, guys. I'll see you next weekend then, and we'll continue this next weekend. So we'll probably be able to cover a lot of. So there is only a little theory left. We're going to look at some of the attacks on TCP/IP, some ICMP issues that you have, right? And then we will start next week with ASA.
Okay. So just one small query. First of all,
Yes.
thank you. It was a great session. I enjoyed thoroughly. So which model you are going to cover, and SCOR and then FTD or VPN model?
So we are going to be covering ASA. We're then going to be covering FTD. Then we'll move to, I believe, infrastructure security. Then we'll move to ICE. We'll then do content security, which is WSA and ESA. Okay. We will then cover AMP for endpoint. We'll then cover Stealth Watch. And we will finish it with Umbrella. So for the most part, we'll be covering the complete Cisco security portfolio. Okay.
Okay, but what I mean, there is 2 modules. First one is SCOR, that is related to all the basic stuff to all the related Cisco devices.
So we are not really, so we are not really covering this module by module, but whatever we'll cover in the training end to end, that would prepare you for SCOR and any of the concentration exam that you want to give. Okay, because we are going to cover FTD, we are going to cover ICE, we are going to cover WSA and ESA. So these, they make up your concentration exams, and then there's VPN as well. Okay, so once we finish the training completely, and we have covered all these products, you should be able to sit for the SCOR and any concentration exam of your choice.
Okay, that's fine. But what I mean, FTD is a separate module, so we are going to cover all these things. And
right, we're going to cover everything separately.
Okay, thank you.
So we'll be covering every product separately and in detail. So that would be basically understanding how the product works, and then we're going to see it, how it works, how do you implement it, and how do you do troubleshooting, etc.
Okay, thank you.
Arun.
Good night.
Good night.